Hello, welcome back to the AI Engineering Crash Course. Today we'll do an introduction to LLMs. This is the third part of the first module of the course, where we'll just be going through the history from the starting point till the LLM, so you understand where the LLM come from and the generations of model before LLM. So it's a high-level overview. We'll not be going through technical details or mathematics here. It's just a means for you to understand what the LLMs are and where they come from. Get started. As we said at the beginning of the course, everything started with data, and the vast amount of data that we generated online brought us to a point where we tried to find ways to use this data efficiently. So we were able to actually get this data and get some key information from the data. And from that data, we wanted to see into the future a bit. Okay, so we wanted to create some correlations between what happens before and what will happen next. And this drove us to an era where we had amazing technologies that only help to predict the future. So say predicting the future is a bit old here, but the goal of the technology was to actually try to find correlations between data that we have right now and what could happen in the future. And this technology brought us to machine learning. And what exactly is machine learning? So machine learning is a subset of data science that study, or it's a subset of data science that actually aim at creating models that are able to predict values of new data based on past data. So let me just give you an example here. Let's say we have multiple points like this. Okay, we have a data like this, for example. The goal of machine learning is to say, hey, I'm seeing a kind of correlation here. Maybe this actually looks like this curve. And if we just in the future, maybe have a point like this here, we may guess and get its value. And this is in some kind of, something like this. I hope you understand mathematics, otherwise it's not fun. So we do this, we have this. And if the goal is to say, okay, we have this kind of correlation between the data. And if we get a point here, it's probably something related to something here, and we may get a value from it. So we have so many machine learning algorithms. We have random forest, which basically is a simple decision tree. So you have maybe a starting point here that will say, oh, this happened, then do this. But if it is this, do this, it's kind of simple. It's actually many useful classifications. We have random forest. We have many other machine learning algorithms that are quite interesting. And from this algorithm, you are actually able to either classify things or predict new value based on actual past values that you use to train the model. But the issue here is most of the time you need a strict way of organizing the data, a strict data feature extraction, which means extracting things that will influence the behavior of the model from the data. This is quite complex, especially for all the data we have online. So we try to create a new field that will be like a black box, like a magic spell. So we just give it the data. It makes sense out of this data. And then you just ask for new predictions. So you don't need to know, oh, do I need a decision tree? Oh, do I need a regression algorithm? Or do I need whatever? You just pour the data in and you get something out. And this field is actually called deep learning. So deep learning is a field where it's a subfield of machine learning, where I will just simplify things here, where we try to make things as simple as possible. So we have a set of data. We try to mimic how we think, how the human brain is created. And we give information in and we get information out. It's the same, maybe you see something and it trigger reaction, right? So a lot of neurons in your head made this reaction from the action, from the input that you got. So it's the same that we are trying to reproduce with deep learning. We have a set of neurons. it's still, rounded corners, rounded balls like this. We have hidden layers, some kind of layer. So let's say these are actually, human brains. And we have output layers, something like this maybe. And we try to connect them. It's not okay. So let me just change the color because now it's readable. Something like this. And we do a lot of mathematics. Okay, some mathematics to be okay. So if you give this input, you need to calculate the amount of a lot of mathematics things that will give you the right output based on the input that we gave. And this right output may be the prediction that we are looking for. And most of the time, it works, right? Most of the time, these models are able to capture the correlation in the data that we give to the model. This is quite interesting. So we are now able to feed the data to a kind of model and get back some kind of prediction. So we are now able to predict the future, basically. But the problem is, from this model, we cannot keep a kind of sequence. So if you give some kind of data here, you get input and output. So you are not able to give a structured data to this model here. You're not able to maybe give a text. Let's say you want to translate something from English to French. How do you build this kind of model? Let's say you want to predict stock prices. It's kind of an historical data. You need the strict order of things, but this deep learning model cannot do that. So we come up with different architectures, and these architectures included recurrent neural networks, LSTMs, and then transformers. So this is actually here to help push limits of deep learning that we had, and this helped solve the problem. I think the latest one were transformers that Google published a few years ago. When Google published transformers, we didn't really have a really big breakthrough. After that, I think Google created Google Hello, a kind of chatbot, publish it online based on that, create some models, BERT, and some few models and publish it. But it wasn't that big. It wasn't that huge. It was a great technology, but it wasn't used efficiently. But the power that comes with transformers is actually what? With transformers, with deep learning generally, you have a hard time doing it on a large scale of computer on a really, really big amount of data. So you need it's hard to scale, basically, if you have to put the software terms here. But with transformers, this is actually possible. We can do it on a cluster of GPUs. We can feed it so many data. We can do parallel training. So the architecture is good enough for scalability. And then one company, I think created in 2016, started exploring how to reach AGI. This company is actually OpenAI. And they started by trying to feed the most data possible to a transformer model. They started by creating GPT, open source, GPT-2, open source. And then in 2020 or 2021, I don't remember quite well, they created a model called GPT-3 that has, I think, 360 billion parameters or 200 billion parameters. And we started seeing new features from this model. So remember from the beginning, I said, deep learning model are kind of a black box thing. You feed the data and the deep learning model figure out what to do with it, right? So right now, it figure out what to do with it, but kind of much more than what we expected. It was able to do things that we didn't even know a model can do. So we found a pattern here. Maybe if we scale this model more and more and more, they may do things that will be more and more and more complex. And from there, we had scaling transformers, we had LLMs, large language models. And these large language models basically are just a bunch of data. So if you get a large amount of data, let's say this is data, and you properly feed it to a transformer model, using a lot of GPU and burning a lot of money as well. I think basically now it's like 6 million from the DeepSeek standard. You are able to get an intelligent model at the end. And this intelligent model will be able to have skills that you didn't predict the model will have. So it will be able to converse, to translate text, to do mathematics, to understand physics, and many, many, many more things only based on training data. So most of the time you have a completion model at the end. So here you just have a model that can complete text. So you can say, hello, I am, and it will complete, just say, oh, I'm this guy from this country doing this, because the model saw that a lot of time and know how to work with this kind of data. So what it's doing under the hood is that it is trying to predict, this word based on what it got before, right? And surprisingly, this is working. So it's able to predict coherent text. But now, in order to have a much more specific use case being teach to the model, we need a second step, which is actually either reinforcement learning or fine tuning. So we need to go from this completion model to a model that can do one thing specifically well. And we need to do some kind of supervised learning here, where we feed some real world examples to the model, like let's say a conversation or some text, some code or whatever. And the model will learn from this kind of data. And then we'll be able to do that specific things. The model actually from the base training has some kind of knowledge that will help do many, many things. But now if you specialize the models in one thing, the model will be good enough to perform that thing quite well. So from this large language model, GPT 3.5, we go Chat GPT, which is actually a derivative of the completion model specially made for text. We got coding models, we got many other models for many other specific things. And now we are here able to build incredible apps on top of these LLMs, thanks to this evolution from data, machine learning, deep learning, LLM, transformers, and then scalable AI today. So today you still have some kind of mixed architecture using transformers and mixing it with some other kind of technology or some other kind of routing mechanism. But under the hood, most of the time it's actually just scaling transformers. Hopefully we'll get a better architecture soon that will propel the model to next frontiers and maybe make them more intelligent. But for now, this is kind of the base introduction to LLMs that you may have, that may give you a high level overview of why and how we ended up with LLMs. So yeah, I hope you understood everything from this part. If you have any questions, leave them in a comment below. Thank you for watching, and see you in the next part that will be about API and SDKs. Hello everyone, welcome to the AI engineering crash course. Today we'll do the fourth part of the introduction, which is about API and SDK. So as you can see here, we have talked about AI and AI engineering, the difference between AI engineering, ML, data science, and software engineering. We did a simple introduction to LLMs, and we'll go from this simple introduction to API and SDK. Let's get started. So basically, in the last video, we went from big data, the need for correlation, machine learning algorithms, deep learning, transformers, with just a high level overview of all these things, to here where we have LLMs. But now let's imagine you're a company like OpenAI, build a really big model. It's doing incredible things, but you cannot build everything on top of it yourself. So you try to outsource it to other people. How do you do that? You create a way for these people to access what you did. So we need to find a kernel or a way to actually provide your service or your model to other people to use it for their own use cases. And then here comes API and SDKs. So what's an API or an SDK? An API is actually an application programming interface. It's an interface that helps you access functionality from a system, but restricted. So it's like a proxy. So you have here your system. Okay, let's say this is your app, and you have a kind of proxy here that give you access to certain part of this infrastructure or this application. And you have here a system, like this system is the LLM, for example. Sorry for my handwriting. So your app will go through this API. This entry point is actually like the door. It will allow you to do some things on the model that's being created here. So you actually define at this specific place how everything is being handled. And this specific place is actually an API. So we need to understand a bit more what is an API today. So normally in programming languages, if you have ever built something with a programming language before, you have libraries. So for example, if you take Python, when you want to deal with networks and web applications and routing and everything, you can either do it yourself or you can do it with an application or a library. This library can be FastAPI or Django. Let's choose FastAPI. If you choose FastAPI, what you are doing is actually using pre-written functions to access a much more complex implementation of that logic, right? So this function is actually like an interface for you to access that. This is actually an API. Same for when you try to logging into any other system. What's happening here is that this system will connect to some other kind of interface, and this interface will allow the system to perform some things. So let's take a really simple example here. So you go to ChatGPT and you go to the inspect, you go to network tab, and you try to type something like that, hello world. You will see that there are some things happening here. These things are actually calling an interface to ask for some specific informations. So this app that you're trying to interact with right now is asking to some kind of system, can you autocomplete this for me? This guy said, hello world. What else can come after hello world? And then the system will just say, okay, this is your response. So you, as the front end or as this app, you don't need to understand or know what's happening under the hood of this system. You just need an entry point and an output format. Okay. And this is your communication scheme. And same for all the systems that have been built using LLMs. You need to access some kind of API. And as we already presented them, I'll just show you here what those API are for Enthropic and OpenAI. So here, if you go to the OpenAI documentation, you will see here OpenAI developer platform. So if you go to the quick start page, you'll see here that you have they're explaining how to access your model. You need OpenAI key, of course. So what you need to do is to go to your account, go here, and then your profile, and then API keys. So when you click on API key, you will generate a new API key. Create a new API key, and you give a name, and you select a project, and you create a new API key. And then this API key will actually be like your pass. So here, this guy will say, oh, do you have an API key? Is it valid? Okay, I can give you access to all this system. But if you don't have an API key, let's say you are someone in red here, you come here without an API key, it will say, no, I cannot give you access to my LLM. You need some kind of key to access this party. I don't know how it calls. This is the role of an API, to actually be the proxy between everyone accessing a system and the system itself. And in our case here, the system is the LLM. It can be OpenAI LLMs, Enthropic LLMs, or whatever else. And as you can see here, when you get your API key, you can go back to the documentation again and go to the quick start. When you get the key, you need to click here. You have a kind of standard way of accessing this API. This is a normal HTTP request. So normally, whatever you do in the browser, it's actually sending some kind of HTTP request. So if you copy this link here and go into Postman, so it's simple, just type Postman on Google, you create an account, and you're able to access it. I'm already logged in, so normally you create an account and you have access to Postman. Otherwise, you can download the app as well on your local computer, and you have access to Postman as full. But if you have any question, let me know in the comment. I will help you. I will do a simple tutorial representing Postman if you don't know how to use it. But here in Postman, if you paste the URL here, and you need to come to the authorization here, they mention in the API that you need the header authorization. So you need to come here, authorization, URL token, and paste your API key. And then content type application JSON, normally it's by default. So we have here content type application JSON. And you are now able to access the system. So you have the keys, you have access to the party. So you can just come here, copy this, and now you can ask whatever you want to the model. So if you ask here, tell me more about yourself, and we send this, it takes some time, it verifies your key, make sure everything's good, and you get a response from the AI. So this is the base way to access this API. As you can see in the name, we have API already. I am an AI language developed by OpenAI. This is the response that you get from the model. This is the format that you agree on with the provider of the API. You actually need to have 3 different components to access this specific API. You need a key, you need some kind of headers. This is simple things. You need some kind of input, and this input will be how the system agree that you will communicate with them using that specific format, and you get some kind of output. And this output is actually what they prepare for you, and you get the output and you work with it. This is like the application programming interface. So this is the interface between you, your app actually, and the system, which is LLM in our case. So it can be anything. GitHub has a public API. SpaceX has a public API. You have a lot of applications that have APIs out there. Google Drive, Google have an API for you to manipulate your files. So a lot of systems out there have APIs, and these APIs are all the way for you to access their system, but in a protected way. So they can manage what you're doing, where you're doing it, and how you're doing it. So that's the reason why you actually most of the time need a key to access these systems. Now, you can see that doing this is kind of tedious, okay? If you're building an app, sending HTTP requests for everything that you need to do is hard. It's just repetitive. You need to build everything yourself. You need to understand how their system work inherently. You need to understand, okay, I need to send this format, and I'm getting this format. And they have so many different formats here. So if you check for after authentication, you will see you need temperature. So you need to understand a bit more, getting into a bit more what they are offering in the API. You don't have to do that, right? We need a simple way. We have a simple way to actually access these systems. This is what we call an SDK. An SDK is actually a software development kit, which is provided most of the time by this API reference. This is the API reference just in case you need to, do it manually using API, role developer, the header, you need to set them yourself, the key and everything. But they provide also an SDK. So the SDK is a simplified way of for you to access these systems. So if you come here again and you come to the JavaScript, you will see that you install this and you just directly use the system without having to care about which URL it's using under the hood, which headers it is adding, and where to put the authorization key. You just have like a simple interface that will help you access these systems. So this is what you call an SDK. So normally when you develop an API, you have a layer on top of it that will help facilitate access to your API, which is an SDK in our case. And in right now, almost all the providers have some kind of SDK or some adaptation to this SDK. The OpenAI SDK is the most popular one because they have you have a specific trick to actually support many other provider using the OpenAI SDK, using the base URL. And then Enthropic also have an API reference, and they also have the SDK. So if you click here, you can get a key, of course. But in Python, you need to install a package called Enthropic, right? And this Enthropic package will give you access to this thing. You just need to say, oh, client.message, just create a new message. You pass the model, the max token, the temperature. We'll go through these parameters a bit later. And then this is the input data, and you directly get the output. But if you need to have the API reference to actually send this request yourself, this is the URL, this is the header, This is the header. You need to actually set this yourself and actually manipulate the API yourself. So if we have to resume, API is actually application programming interface. It helps you access other systems, but in a secure way and in a more restricted way. So whatever you do on the Enthropic API, they will know it's you because you have a key. That's logic. So they have like a protection layer on top of just system that give you access to specific part of the system. And then to simplify things more, this provider create SDKs. And this SDK gives you much more simplicity over HTTP requests, header setting, and many other things that you can do with your system. So I think we went through everything we needed to say about API and SDK. Thank you for watching. In the next part of the tutorial, we'll talk about Python and JavaScript in general, and then the programming language we'll be using throughout the whole course. Yeah, thank you for watching and see you in the next part of this crash course. Hello everyone, welcome back to the AI Engineering Crash Course. Today we'll talk about Python, JavaScript, and UI. So in this video, I'll just be giving you some advice, giving you some tips, giving you some libraries, giving you some tools to help you learn and understand JavaScript and Python so that you can go and start confidently this complete tutorial. I'll also be giving you some UI tips just in case you want to extend the project a bit more. And yeah, so this is the last part of the introduction where we went through AI engineering, ML, data science, and software engineering. We went through some kind of history of LLM. We talked about API and SDK, and now we're talking about programming languages and UI. So it's just a global introduction to the whole course. And then after that, we'll talk about prompt engineering. So we'll go through prompt engineering challenges, why you need to understand prompt engineering. We'll talk about parameters that the model gets and why it matters. And then we'll talk about zero shot, few shot prompting, all the prompting technique that you may need to know as a programmer or as an AI engineer. So get started. So from the last video, we went through all this, explaining machine learning, deep learning, LLM, SDK, and APIs. And as you may have seen, most of the code that you have here are either JavaScript or Python, right? So we need to choose. It doesn't mean you cannot build LLM with other programming languages, as I mentioned it, as I showed it using our Postman interface. This is just an HTTP request, and this HTTP request can be reproduced by almost any programming language out there. So you can create your AI tools with Go, Java, PHP, or whatever you want. But you just need to, you will just lack the SDK and a lot of libraries. So it will be a bit harder, but you can do it. So this is the reason why we have to choose between Python and TypeScript in JavaScript in general. But for the sake of simplicity, we'll go with Python. We'll be working with Python throughout this whole course. But as you will see, these libraries are basically the same. So if you learn either Python or TypeScript or JavaScript in general, you will not be missing something. You will have the same API, you will have the same SDK, despite the fact that the Python environment is a bit more developed for machine learning, AI engineering, and everything. You will basically have the same thing. The advantage with JavaScript, on the other hand, is that you can build full stack applications, really reactive applications directly with AI using incredible libraries that I'll be showing throughout this video as well. So, yeah. Now, how do you learn JavaScript or Python? I will put in the description of this video some really great course that will help you get started with JavaScript and Python. But if you know JavaScript and Python already, it's good. So you don't need to learn again. You can just go to the next part of this video, which is prompting, and start learning from there. Also, concerning the installations that you need to work, you just have to go to Google and type Python. Oh, sorry. Search for the logo of time. So you come to the python.org. Pretty simple. You have a download. You click on these. You will download Python and you will install it. As simple as that for your operating system. So you have Mac OS, Linux. It's actually on almost all the operating system unless you want to program on your phone, but you can install Python almost everywhere. So as you may see, Python is pretty simple. The language is kind of written to be as easy to read as English. So you just define a function while this happened, print this. It's actually an easy language to learn. Same for JavaScript. So you can choose either of them, but with this tutorial, we'll be going with Python. Now, what about UI libraries? We will be using Streamlit because we went with Python. But if you want to know about more about other libraries that are out there that you can use to build AI application, you have React, which now needs some kind of framework behind it. React is a really good front-end framework that can help you build front-end pretty quickly. You also have Next.js. I think it's a go-to solution most of the time because they have the AI SDK, they have simple integration, they have direct backend, and it's the easiest way to get started with front-end. So you need to go to the Next.js page and start learning. They have great tutorials. You can see a lot of content also out there on Next.js. And if you want to know a bit more about Streamlit, it's a simple solution to help you quickly prototype applications so we can use it in our process just to create some quick UI to test our application and test what we are doing. So as you can see here, we have this simple line that will create this simple app for us. Same as for everything, you just come to the web page here. You have the line to install Streamlit here. You click on it, and you will be installing it later, and you install it. And normally when you say Streamlit hello, you'll see something. For the UI, we don't really have a UI. Otherwise, we'll be using either V0 or bold.new, but we don't really have a UI for the moment. We'll be doing everything with Streamlit, so everything is good there. In terms of tool that you need to install, I think I gave everything. Python, you need to install Python. And then I will show you how to install Streamlit, how to install all the packages that you need to work with Python. And then lastly, at the end of the video, or with the project that we're doing, we'll integrate Fast API. So just need to type Fast API. As the name suggests, it is a quick way to make APIs. And we talked about API before, so you need to understand. You must already understand what an API is. So this will help you yourself create your own API pretty quickly. We'll also be showing the whole process of installing it, configuring it, and working with this. So yeah, I think we went through everything we need for this tutorial. In the next part, we'll talk about prompting challenges, and prompting in general, prompting techniques and everything. So this is the end of the first module. See you in the next module. And don't forget to subscribe. Forget to say that. And comment if you have any question or any issue. Thank you for watching, and see you in the next one. Peace. Hello and welcome back to this AI engineering crash course. In this second module, we'll talk about prompt engineering in general. And in this video specifically, we'll give you a broad introduction of prompt engineering. So let's first start by going through what we did before. So in the first module, we had a brief introduction about the AI engineering field and what's the difference between AI and AI engineering. We also gave some difference between AI engineering, ML engineering, data science, and software engineering. We gave a brief introduction about LLMs and where we came from to have LLMs today. We talked about API and SDKs. We also introduced Python and JavaScript and some UI libraries. So in this new module here, this prompt engineering modules, we'll be talking about prompt in general. We'll also be talking about a few terms that you may hear, that you may encounter while working with LLMs, which are token, temperature, pricing, and max tokens. And then we'll do a long video giving you some of the prompt engineering techniques that you may need to know while working with LLMs as a software engineer or just as an end user. So let's get started. So let's first start by defining what prompt engineering is. So, from the video about LLMs, we had a really long introductions to this new architecture. So it went from machine learning to deep learning to RNN to transformers to large language models. At the same time, we started with computer and we were able to actually give instruction to these computers using extremely low level languages. We used assembly, and then we made it simpler, like with C, C++, and then Python, and then JavaScript. And today, we can actually instruct a computer to do something with natural language. But the problem is, we first started with a strict language because it gives some kind of base for everyone to write a clear instruction that the computer can understand. So if we say two same things at two different people in natural language, they may hear two different things. So if even between us humans, it is hard to communicate using natural language, how hard will it be for a computer? So having a clear set of rules and a specific way to communicate with these models are quite important. Otherwise, it will be pretty hard to get the expected output. We will have a lot of unexpected results. In the word prompt engineering, we have prompt. A prompt is actually an instruction in plain language that we give to an LLM. It can be write a specific text for me. It can be solve a specific problem for me. It can be go online and do these specific things. And prompt engineering is a field that give you the tools and process to write better prompts. So let me give you some overview of challenges. If you take two different apps, let's say you have ChatGPT 1 and ChatGPT 2. If you write two different prompts from these two applications, you will have two different apps, completely different, based on the prompt. So if the first ChatGPT you say, be free, speak about everything, normally without any barrier. And the second one, you say, only talk about books and talk like Harry Potter, we'll have two different outcomes, right? So you need to know how to write the best prompt to actually get the best output, the expected output from your model. So this comes with a lot of challenges. How to write in plain language instructions that a large language model can understand. And also how to format it, how to get the best out of it, because we have a lot of ways to say the same thing in natural language. So how can we make sure that we have the best way of communicating our intention to this model, knowing that the language is not actually strict? So the field of prompt engineering is actually helping to structure that and give you the tools that you need to actually write better prompts for your AI application, and for your day-to-day use of AI. So, yes. So when we first had LLMs, people started noticing that we can just get answer from plain English, right? And then we had few people giving some different complex prompt and getting different results. And we started having a research on how to improve the accuracy of models only based on different prompt techniques. So we got zero shot prompting, few shot prompting, chain of thought, React prompting. So all of these techniques are actually documented research that you can look online and see how it improved the accuracy of the models. But what I can say in general is that maybe in the future we may not need that level of preciseness in writing prompts, because we'll have far more better models. But even in that case, you need to be able to communicate what you want to the model. So if you're not able to do that, you will not be able to get the expected outcome. Second point that I wanted to talk about in this video is actually security. So if you have a really weak prompt, everyone can jailbreak your prompt. Jailbreaking a prompt means hacking the prompt to make the AI system do what it was not instructed to do. So if you just say to an AI system, you are a coder, just give code, and someone come in your prompt and come in some message and change what the AI can do, it can actually direct your app to do something completely different. It's something that happened to, I think, Canadian Airlines, where they had a chatbot that were supposed to help people book flights, and unfortunately it made some mistakes. People were able to use it for other reasons. So the prompting of your model also involves the security of your model. So you need to make sure that your model is actually secure based on the prompt and based on the instructions. You need to make sure that your model do not hallucinate a lot. We can mitigate it with retrieval augmented generation that we'll talk about later. But from the prompt, you can actually reduce the level of hallucination of the model as well. So I think we had a brief introduction to prompt engineering. In the next part of this module, we'll talk about tokens, temperature, pricing, and max token. And I will give you some brief real world example on how to improve your prompt in the OpenAI playground and how to play with the parameters. So thank you for watching and see you in the next one. Peace. Hello, welcome back to this here engineering crash course. Today we'll be starting the second course of the second module, where we're talking about tokens, temperature, pricing, and max token or max content length. So we'll be defining this word and kind of explaining what they are and how they matter when you consider LLMs. So let's get started. So in the past videos, we did an introduction. We did a simple introduction to prompt engineering. Now we're talking about tokens. And in the next video, we're talking about prompt engineering techniques. So basically, what is a token? A token is a unit of word, a kind of word length, not really word length, but a chunk of text that being used to train models. So we consider while training a model, not a set of words, but a set of tokens. So if we take a text like this, you may see that this is a token, this is a token, this is a token. So usually it's a word. But for specific things like maybe abbreviations or words that may have that you may need to truncate to be able to understand or to be able to extend them based on some specific configuration, you may have to have one word being two tokens actually. So let's just say token is the word in the world of AI. So it's a word in the context of AI. And each different model have a different way of having these tokens. It's actually based on the way you train the model. So if you have the tokenizer that you use, define how the token that you pass to the model will be calculated. So you can have two models, but have two different calculations of the number of tokens that this model take. So let me just give you, I think maybe you know this already. This is the ChatGPT tokenizer. So you just have to type OpenAI tokenizer online and you'll see the first link is the tokenizer. Here you will be able to just type any text and get the number of tokens that the text have. So you can see, for example, here that I think it's deleted. So let me just paste this again. That we have here, okay? You can see that OpenAI is actually two tokens. Normally, you will say it's a word, but in this context, it's actually two tokens. But the rest of the words that we have here are basically just words. And you can see that this dot at the end is a token because it's important for the global context of the paragraph. And if you take the word text here with the point, it doesn't make sense, right? You need to have the point alone to be able to fully understand the structure of the sentence. So the tokenization of this text is actually breaking it into tokens. And these tokens are just units that you pass. I think it's defined somewhere here. Sequence of character found in a set of text. Yeah, so you can say it that way, but usually it matched to the amount of words with some kind of adjustment, maybe the punctuations and some words that are divided into multiple tokens. So it's a bit more than the number of words that you have in the text. I think DeepSeek, if I'm not wrong, DeepSeek API has a really good way of stating that somewhere. Let me see. I think it's called token and token usage. You will see that for them, one English character is 0.3 token in their training set. But if you consider here, one character or one word is actually like, you can say a token is like more than 3 characters actually. And you can see here that one English character is actually 0.3 token in your training set. Yes, and if you need to calculate the tokens for DeepSeek, you need to download a separate module and use it offline. So As you can see here, a token is just a way to represent the text into chunk that you will pass to the model. It is not exactly words, but it is a representation of the text in a word way for us. So when we have a sentence, we have a set of words. But when the AI sees the sentence, it sees a set of tokens. And these tokens are defined when you're training the model. So now, what is the max token of the context length? Usually when training the model, the architecture, the transform architecture require a specific fixed input length. So this will be like 128K for most of the model out there. And the issue is when you double it, you may triple or quadruple the price of the model, or just lose the quality of the output. So we need a maximum amount of tokens that you can pass to the model to keep the cost low and also ensure the quality of the output. So that's the reason why you have max token. And for many of these models, it's around 128,000 tokens. So basically more than a book. Not more than a book, like more than a small book, actually. But I think Google just had created a model last year that takes 2 million tokens as input. But the issue with that is also some small misunderstanding of sentence in the middle of the tokens. I think it's called loss in middle, if I'm not wrong. So having a really long context length is good, but it may cause some problems. And the context length is linked to the model training set, and also to cost optimizations and also performance related topics. So now, what is the temperature? So if we come to the playground here, you will see that our model is a probabilistic model. It's actually predicting the next token in a sentence with some kind of probability. And you can put some randomness to this probability, right? And this randomness is represented by the temperature parameter that we have here. So if you say something nice to the subscribers, I don't know, something like this. I don't know if it would say something interesting. It will say hello, wonderful, something kind of, creative. So if I ask the same thing again, yeah, let me just delete this because, okay. So if I ask this again, you will see the text is actually different. So every time we have some kind of randomness in the probabilistic creation of the next token, that makes sure that every time you ask for something, it gets something completely different. So if we reduce this to 0, the temperature to 0, and we ask the same thing here, it says this, right? Keep this in mind, keep shining bright. If we delete this and we ask it again, keep shining bright, you will see that we kind of have somewhere the same structure of sentence that we had before. We delete this and ask it again. You'll see that we get something pretty similar to what we got before, keep shining bright. So it's actually getting around the same sentence over and over again, the same sentences. And yeah, so that's the reason why temperature is important. But now choosing the temperature depends on the use case that you have. If you have a coding use case, you need a really, really low temperature because it's a strict programming language. You don't need a lot of changing in text. You need a strict code output. Same for mathematics and engineering. But if you need creative coding, the temperature needs to be at maximum, at 2 maybe, because you need the model to create new things that each time you ask for a new poem, right? I think DeepSeek has a really good way of placing that. I think you can see it in the API somewhere here, temperature parameter for coding 0, for data cleaning 1, for general conversation 1.3, for translation 1.3, for creative writing 1.5. So you can maybe use it as a set when setting up temperatures, but in general, yeah, you can set it up in the playground here. Same for max token. So I talk about max token as the limit that the model gives you, but you yourself in your app, you can actually define a max token. And this is one of the parameters of the model, right? So you can just say, okay, I want maximum this amount of token for the AI to say, okay, I will limit the response output to this amount of text. I will not go further than that. It can help you reduce costs for use cases where you don't want the model to start saying long text when it doesn't need to. So what about pricing? We talked about tokens. The model is usually priced on a token base. So it means if you have a long context, which means a lot of tokens, you will probably pay more. it depends on the model that you're using. For DeepSeek, you may have a really long input length, but the price is so low that you will not have the price, you will not see the price coming. But same if you go to the latest model of ChatGPT, you may have to pay a bit more. But now when you go to an open source model, you're not really paying for the input token, but the resource that is hosting your model. So now you are not counting the price based on token length, but now based on the infrastructure that's running your model. So that's a consideration you need to have, especially when it comes to hosting the model yourself. We will be talking about that later in the video. But in general, pricing calculation is based on token lengths when you use external API providers. Yeah. So I think that's all for this video. We went through the specific terms that you may need to understand while just playing around with LLMs or just trying to understand the concepts. So in the next video, we will talk about prompt engineering techniques that you may use while coding or while using AI app in general. And if you are new to the channel, don't forget to subscribe. If you have any questions, leave them in the comment below. Thank you for watching and see you in the next one. Peace. Hello and welcome to this here engineering crash course. Today we'll go through the third part of the second module about prompt engineering. And today we'll talk about prompting techniques. In the last few videos, we talk about AI and engineering in general, programming languages, and many more. And in this module, we talked about challenges of prompt engineering. We gave some and defined some terms like token, temperature, pricing, context length. And in this video, we'll go through different prompt engineering techniques. So let's get started. So in terms of prompt engineering or prompting techniques, we have a lot of different techniques. The first and simplest technique is actually just telling straight to the model what to do. It's basically generally associated with zero-shot prompting. It means you just say to the model, please do this. So we can go here, for example, and say, your useful assistant is actually just a zero-shot prompting technique. So you can just say, be cool. This is a prompt, right? And then you can add a user saying, hello. Based on that prompt, it will answer. The prompt is actually correct, right? Now, if you want the model to be more accurate, you need to be more specific in your zero-shot prompting, of course. And for that, you have different ways of organizing the prompt to make it more interesting. First, you need to play a role. So you need to do something like role. You are something. You are an AI, let's say YouTuber with 10 subscribers. And, you explain what you kind of extremely describe the role of the AI in this case. So the AI will take that in mind and try to act as this person. And then now you can say, give the context. The context is like, okay, you know this, you should know this, you should get this, these kind of things. You should be able to advise people on YouTube. And then now from this role and this context, the AI have like a persona. From this persona will represent what the AI will try and mimic in the response. You can actually set the tone as well. If you want to, like the tone, speak like Elon Musk if you want to, or speak like a professional person, speak like this kind of person, and then you can give the task, okay? I'm just giving these parts just for reference. You don't need to write them. You may want to, but you don't need to. And then the task will be help users with their YouTube channel. So when you give this to the model will try to be as close as possible to the persona that you created, and will try to act as much as possible to the person described in your prompt. So this will give a bit more correctness to your model, to your output, because it will try to act as the person that you created, like the YouTuber with a million subscribers. If you just say, help me with my YouTube video, you are more likely to get a generic response than help me with my YouTube video. You need to know this and you need to speak like an advisor with this kind of tone and this and this and this. You get more accurate response with this normal zero-shot prompting. So now with this, you are still out there describing a persona, but the model does not know how you want the output to be. It knows how you want him to act. But if you want to show to the model this is the kind of output I want to have, you need to go next level to the next level and actually implement future prompting. And future prompting is actually pretty simple. So what you do is you give to the model few examples of what you're expecting. So it can be if you want the model to be able to generate YouTube script, you will say input video about AI and output the, the format that you want exactly. Okay, you do the same maybe 2-3 times like this. Oh, okay. And then now you can put the input here, video about data science, and then you put output empty. The AI will try to guess from what you gave as input and as examples what the output may look like. Right? So from this kind of task, giving an input and output to the model, define a bit more the structure that you want, the format that you want, the way you want it to be, more than the persona, more than the description that you gave. So if you give some kind of JSON output here, the model is more likely to give you a structural output in JSON as well. That's the reason why future prompting is actually pretty powerful. You give to the model the exact format and exact tone and structure of the output that you need, and the model learn from it to be able to generate something that's pretty close to what you gave. Yes, but apart from that, we have different other techniques here. So before going to React prompting, I first want to explain chain of thought. And to explain chain of thought, I need to go and show you the deep thinking of DeepSeek, because it's actually used some kind of chain of thought. So let me just firstly quickly explain this to you. This looks like future prompting, right? You give a question, answer, question, and you expect a different answer. But now, in the example that you give to the model, as I mentioned, the example give the model the direction how it's supposed to give you an output. And in our case here, we describe in a kind of structural way, in a kind of chain, how the model should think before answering. So here you say, Roger started with 5 balls, 2 can and 3 tennis ball, each is 6 tennis ball, and then you do 5 plus 6 is equal to 11. And the model will understand your the structure you want him to answer with, and then will mimic it. And by mimicking that, it is more likely to come up with real and accurate answers. So that's the reason why chain of thought is actually quite interesting. So if you look at DeepSeek, if you go to DeepSeek and you try to search for something, let's say, how are you today? You will overthink this question surely. And you activate deep think as specially. So it will be, this is just a generation from the model. So the way you have this is you train the model by giving it the think part and the response part. The model learn how to think and respond at the same time. And this is kind of a chain of thought that we talk about. So this structure here is from the training set given to the model. So the model knows now that when I get a question, I need to have a thinking step before having the response step. And this thinking step is augmenting the accuracy of the model in some sense. So as you can see here, I don't know why he's overthinking the message, but in general, at the end he said, yeah, looks okay. How can I assist you and everything? Yeah. And then the last technique we'll be seeing in this video is actually React prompting. So here, for example, you have a simple prompt with thought, act, observation, thought, act, observations. And this will give the model, as in chain of thought, a process of solving problems, right? And when the model will get a new input, he will go through the same steps, follow the same process to solve the problem. here the process is an organized thought with one act, some kind of action that the model will do, observation from both of the thought and the act, same, and at the end you get an output from the model. So this makes the model also more accurate, same as the chain of thought. So you have much more prompting techniques, and I will put this link in the description. You can learn a bit more about all these prompting techniques there. A bit more about RAG. We'll come through it later. And yeah, so from there, I think just with few short prompting, with chain of thought, and with React prompting, you can actually write extremely good prompts. And what I explained during the zero shot prompting phase, you have, I think, the knowledge to actually create really great prompts. But what I have to say as well is you need to balance the length of the prompt with the price, right? It's like a threshold that you need to find, because writing really long prompts costs a lot of money because you're sending the prompt every time. We have prompt caching now, but in some cases you need to send the prompt every time. If you have to send a prompt that costs $1 every time, your app will cost a lot to the users at the end. So you need to be specific in your description, but you need to take into account the price of having a really long input token as well. So if you have any question, you can put them in the comment section below. Yeah, thank you for watching. And in the next part, we'll be exploring now each of these providers' API. We'll go through OpenAI API, Enthropic, Google, DeepSeek, XAI, Drog, all of the providers' API, and go in depth in everything you need to know. So we'll take, for example, OpenAI API, go through all the functions that they provide in their SDK, and I will show you how to use them in real-world application. And then afterward, we'll go through all other providers, and then have a quick overview of LLM frameworks like Langchain, Haystack, and Llama Index, and then we'll create a project at the end in the next module. So if you're excited as me to reach that module, don't forget to subscribe, and yeah, see you in the next one. Peace. Hello everyone, welcome back to this crash course. Today we'll introduce the third module of our complete crash course, and we'll be talking about providers. This is where you actually learn how to use LLMs, APIs, into your application, either via direct SDKs or with frameworks. So let me first give you an overview of what we did already. In the first module, we introduced AI in AI engineering. We went through what's the difference between API and SDK. We actually gave a global introduction of everything we'll be having in this course, as well as the tool that you will need to understand every concept that we'll be explaining. So in the second part, we talk about prompt engineering. We gave some prompt engineering techniques, what you need to learn prompt engineering, some few words that you may have or encounter while working with LLMs. And then we gave few prompt engineering techniques that you as a developer need to know to be able to instruct the model properly. In this part of the course, we'll talk about APIs themselves. So this is where we actually start coding and going through how to use the LLM to build products. In this module, we'll talk about OpenAI, Enthropic, Google, Drug, XAI, DeepSeek. Actually, all of these big providers will teach you how to use them in your own project, and we'll go through different other way of achieving the same result using frameworks like LangChain, Haystack, and Llama Index. We'll also have a brief introduction about Together, OpenRouter, and Replicate that we'll be coming back to in the open source module. And then at the end, we'll have a practical project. So let's start with the OpenAI overview. So as you can see here, we have an empty folder or an empty project open in VS Code. So what we need to do is create a folder for OpenAI where we'll be putting all the code related to OpenAI. And here we open a new terminal. We go to the OpenAI folder. The first thing that we need to do is to actually create a virtual environment. And this virtual environment will keep all the dependency of our project so we don't have to merge them with our global dependency. So let's create that by doing Python and vm called vm. Okay. So when that will be done, you will see a folder called vm in there. And then we need to activate this VMF. We do source VMF bin activate. Okay, so you will see that we have a VMF in front of our terminal now. Every time when you see this, it means you're working in virtual environment. So now we need to create a folder, a file here called requirement. This file will contain all our dependencies. So we'll first start by adding the OpenAI dependency with the current version, the latest one. You need to specify the version because otherwise they can change the API and you will break your whole application. So we need to use this version for now. So if they change things in the future, you need to change the version here and adapt your code to the new version. Same for the python.env. So we save this and we just come here, we do a pip install requirements. Yes, I think it's called requirements.txt. It will not open no such file directory. Requirements. Is it in the right? Oh, okay, it's not in the right folder. Sorry. So we need to put it in OpenAI. Move. Okay. And then now, okay. And then now we install all the dependency that we need to have in our projects. So now we need to create a file called .env and also a .git now. So this is just for local. You will have it online directly, so you don't need to create it. So we just git now, and here I'll put my env file and my VM folders, so I can push it later on. Okay, so here we'll create a file called main.py, and in this main.py will be actually coding everything we need to code related to OpenAI. Afterward, we'll actually structure a bit more what we're doing and provide a Streamlit UI for the end project or for the global project for OpenAI specifically. So here, after creating this, what we need to do is to import some dependencies. So we first import OpenAI dependency. Okay, same for the .env, we load the .env, and then we import OS. So what we do here is that we load all the environment variables. Okay, so to do that, we need a function called load.env. Okay, and then we create a client for our AI to connect to OpenAI. We just do OpenAI and we pass an API key. And to get this API key, we need to get it from the environments. And to do that, we do os.environment and we pass the name of our API key. So let's say we came to this env and we create a variable called API key. We'll be storing our API. So how do we get your API key from OpenAI? Quite simple. You go to OpenAI API, it will get you here. And then you go to, normally I'm logged in, so you will have to log in, of course. And you go to dashboard, you go to API keys, and you create a new API key. So you need to keep this secret because otherwise people will use your money to actually create their own AI. So just click crash course, create the secret key, come to the .env. Here and paste our API key and save the file. So now we can reference it here as, I think it's called OpenAI API key. Okay. So now we have a client. So what can we do with this? We can actually start calling specific functions and doing specific things. And the first thing we'll be doing, so I think I need to comment here, load API key from .env and then initialize client. Okay, so now what we need to do is to go through the API, OpenAI API, and I will be showing you different use cases that you have and how you can work with them. So the first thing that we have is just simple chat completion. Okay, it means you have a chat message, let's say a chat box. So let me just draw that in Escalate Grow. You have a conversation, right? Conversation. Let me just delete. I need this and I need this in black without the round corner. Okay, like this. Okay. The thing that happens is that you have a chat between you and the AI. The AI will say something and you will say something, right? Like this. So you have a field of conversations. So what's happening is that when you will be talking to the AI do not have a context, at least the API, it does not have a context of everything that's before what you're asking now. So you need to keep it somewhere and send the global list of message to the AI. So the AI will have a context of the whole conversation to be able to answer. So if you say here that my name is Jack, and you say, nice to meet you, Jack, and then you ask, what's my name? The AI needs to know that you say before your name is Jack. And to do that, you need to keep the whole flow of your whole conversation. And how do we do that? We create an object called messages here of just misuse this with TypeScript. Okay, which is an empty array. So the first thing that you need to put here is something called role and this content. So this role is system. Okay. And in this system, you put your prompt. Okay. So let's say you're building an app that will, let's say, help you with mathematics. So you need to specify here that you are an helpful math teacher. You can solve, all the prompt engineering related things. If you need more context, I have a video on the channel. You can watch the video on how to create proper prompts. So we just quickly go through it here. I don't have to do this. And then this will be the first message that you give to your system. You don't need to print this because it is the instruction of your whole app. So to put this in perspective, this simple prompt here, what you wrote here, can create two different apps. So you can create a mailing AI that maybe help people write better mails, or a math tutor, or an English tutor, or a coding assistant, only based on the prompt. So this is where you define what your app will be doing. And this is that the part that will differentiate your app from other apps. So writing a better prompt here is crucial. You really, really need to understand how to write better prompts to have better applications at the end. Okay, so with that said, you need to be having this flow of conversation that I showed before. I mean, the AI and you have to differentiate that using this role here. You have the system role, you have the assistant role, which is the AI response, and you have the user role, which is your response from you as the person. So you can do this and have here user may say something like, I need help with 1+1. I don't know. Something like this. And then the response that you'll be getting is actually what the AI will be giving you as solution to that. So let's do that. Let's quickly do that. You come here, you do response is equal to client the chat the compilations. And this part here is quite important. It's these two segments here, because a lot of the SDK are just changes here in parameters. So if you know the suffix, I would say the suffix here, it looks like an API suffix, and the parameter that each of these function takes, you can build anything on top of OpenAI. So let's just do that create. And here we need to pass some parameters. The first is the model. As model, we can choose GPT-4o. Okay, you can choose 4o minim or whatever model you want, GPT 3.5. You're free here to choose a model that suits your needs. And then we have now messages, and messages are actually the flow of messages that you're passing to the AI. You can just put it to be messages. Okay, so with that said, this will actually, you have some other parameters like streaming, if you want the response to be coming one by one, or you want to have everything one time. But other than that, we can directly get the response here, and we need to console log. We need to print response. Okay, so if you come in your terminal here, you clear everything and you do Python main.py. Oh, I need a comma here, of course. You'll see that it's taking some time to go through the API asking to OpenAI, and you will get a response here. This response is a specific object, and if you check here, you have choices. Oh, wait a minute. Yeah, you can see here that we have message as a property of choices, which is the first element of the array. So if we do response dot choices of 0, dot message, you will get the whole response from the AI. I think it's kind of formatted right now. So let's play this again and open this like this. You see that you get this task completion message with content. So you can just do that content to get the content directly if you want to. And you are getting, certainly the equation is something like this. So this is the first use case. Let's say we completely switch use cases. We want an AI that gives you advice on mental health. Let's suppose we can build something like that. You are an empathetic, how do we call it? Empathetic. I think it's just, that's not the right way of writing this. Empathetic. See, and you help people with, I think they will block this, but let's see, mental health. I need more, I don't know, more joy. So let's try it out. You'll see that we have a different app just based on this one. So let's try it out. Okay. So you can see here, I'm really glad to reach you, wanting more joy in your life. You know, this is a different use case. So we went from a math tutor to an empathetic C only based on the prompt. That's the power of LLMs. So, and the power of prompting. So now you see the importance of having a good prompt into your application. So now that we have this base and we know that, okay, we can do many things just based on the prompt, we can also, I think when you use ChatGPT, you have, the text coming one by one. To do that, you need this parameter called stream is equal to true, and the response is quite different in that case. So you don't get response this way. You get response as chunks, and you need to loop over the chunks. So how you do that? You do here, you call this response, okay? For chunk in response. You can actually stream this directly to the front end so they can, show it progressively. This will make your app faster. From response. Now you need to say if the chunk that I have right now, the choices of 0, the delta, that content is not none, so it exists, you add it to a kind of text. So this is not useful. Normally you need to stream it somewhere, but I'm just trying to show you how to do that. So you do, let's say, full message. Okay, and then you just do full message. Yep, that's the right way. Plus equal to what we just said here, chunk delta. So we add each chunk into the full message. Yes, and then that's all. We just print full message here. Okay, so let's try it out again. Okay, you see that you get a response here directly from the streaming the response from the AI. Quite interesting. So now I need to show you how to do much more complex things. So we went through a simple text generation or simple text completion. And by the way, when you get this response in a normal chat, you need to add them to this array. So normally you do something like messages that happened, full message, but in this format like this, role, assistant, and then content, full message. So you keep track of everything that's going through the conversation. With that said, we have everything containing base completion. Now we can go to the next part, which is structure output. So now let's say you want to build something pretty strict in terms of output. It means maybe some app that will extract key information from a document, or some app that will extract key information from a simple text. So let's say you give a text and you want the AI to be giving you the introduction, the body, the conclusion. But in this case, if you get a text like this, you cannot really, go through it and parse it. So you need a structure output to get it. It's the same as using it to predict something, okay, or using it for stock exchange. So if let's say you want to use this for trading, if you want to use this for trading, you need to give maybe some stocks and get back some predictions. And these predictions need to be not text if you need to act on it. So you need a structural way of getting this result. And structural output is a way to do that. But for that, you need another module called Pydantic. So that's the reason why we go in our requirement and we put the Pydantic file and then clear this and we do a pip install requirements. It will install everything, including Pydantic, if it is not already installed. So you can see here, already installed here. Okay. And then in your code here, you need to specify the format of your output. And to do that, you need to create a class, some kind of class. So you come here, you import from Pydantic, import base model. Okay, this base model, you will create a class that inherits this base model called class, let's say, stock prediction. And you pass the base model. Okay. And here we're just giving the keys that you need. Let's say you need a stock name or code, I don't know, which is a string. Then you need action, which is also a string. Let's say you do something like this, okay? And you say you are an experienced trader. Give me trading advice on stock to buy and actions to take on these stocks. Okay. Okay, let's give this to the user input here. Okay. And then you need to pass a new thing here. I think it's still in beta if I'm not wrong. So you need to do beta chat completion. And here, instead of create, you need a parse. Okay. And with the model, you actually need the 4.0 or one of the latest version of 4.0. So if you use one of the earlier version, you will not be able to get this this functionality. So like just trimming, yeah. And then we put some parameter here called response format, which will be our stock prediction. Okay, so let's see. We run the same as usual, Python main.py, and we are getting some error saying stock prediction base model big B as imported. And now client.beta path got unexpected. Okay, we cannot stream this, so let's just comment this. But in this case, we need to we cannot do this, so we directly need to get I think here response the choice of 0.message, and you will see the format. Let's see the format first. Taking some time. Okay, you'll see that we have a structure thing here. It will say Tesla, consider buying any dip around this potential, market. You can give it a bit more instruction like code to say buy and value to say this amount, and it will be more strict about what it will be giving you as output. So now you can parse this and say, okay, the stock name is Tesla and the action is buying it, right? So this structure output may help you call the LLM as an API to do some specific things. It can be parsing text, it can be extracting key information from data. It can be much more complex things. You can actually do this, use this to do really, really complex app and use the LLM as an API. Okay. So with that said, we need to go to the next part. After the structure output, we need to talk about the vision model. the vision model of OpenAI. This will help you pass images to your model, and these images can range from just simple text on text-based image, or with complex images with complex things on it, and the AI will use this as context to your conversation. Okay, so let's say you want a simple AI that will explain memes to you. Okay, to do that, you need to use a vision model. You pass the image of the meme, and the AI will be able to predict or give you an explanation of what it means. Okay, so let's try to create that. To do that, we have simple changes to do here. So let's hear the prompt again, pretty important. You are the meme lord. Okay, you can explain and understand every meme in the world. Usually pass it. We can also add that, I don't know, you pass your whole day on Reddit. Yeah, so we can just say, explain this meme to me. Okay, explain this meme to me. Okay, but here, instead of stopping here in the content, I think we need to change this way, like this. And we pass first a type, not like this type, and this type would be text. So we need to specify when we are passing text or image. So we pass text. It would be the man. Okay, the man will be text. What we ask for is explain this meme. Okay, and then we need another key called image URL. You can also pass base64 image if you have local images. So let's just say image URL. I'll just look online for some random meme. Okay, I don't know, let's just say something like this. We copy the URL, copy image address. We come back to VS Code and we paste it here, like this. Okay. But in that case, we need to put this image URL instead of text. Okay, and then we call our function. We remove this. We can just directly get the choices, and okay, getting some errors saying beta chat compilation pause. Okay, let me check that. Okay, that's right. So here, instead of this, we need URL like this, and then we have our image. Okay, so we try it out again. Okay, this meme construct how design and programmers stereotype react to similar stole my idea. You saw the meme. So yeah, you can do something like that. So you can pass images and have specific use case where the AI will be going through the image and maybe doing some specific things, like maybe extracting information. It can be extracting text. So you can do that as well. So you pass an image of maybe a PDF or something and ask the AI to extract the text in there, and yeah, many more. So this is a simple overview vision model from OpenAI. So now let's go to the next part, or maybe I'll just show you quickly how to do the same that we did here with local images. And for that, we need to encode this image in base64. So let's say you have an image here. I don't know. We'll not really have it. You have to use real image. So let's say you have an image in base64. You need a function to decode this image. You can get this simple function here from the official documentation. So what it does is you need to import base64, of course. Okay, so what it does is it opens an image that you pass by the image path, and then it read the image and encode it in base64. Okay, so what you give here, so it's like so here type image URL, and the URL will actually be something like this. So let's first get the base 64 im is equal to encode image, and we pass the path here. Okay, image, and then here instead of these, you pass the, it needs to start with base 64, and so you can just format it like this. And then here you pass the decoded the base 64 image. So now it will read this image locally. Let's say it's a PNG. And then pass it to the model to do specific things on it. So you can do the same via by getting the image directly from a request. So maybe someone upload an image on the platform. You pass it in base 64, you encode it in base 64, and you pass it to the model. Okay. So I think that's all for the vision part of this overview. So let's go to the function calling. So what is function calling? Let's say you want to build a system like Siri with this. For the moment, all we can do is just give text and get back text, right? So how do you do to fetch the weather? How do you do to play a song on Spotify? How do you do all of these things that, you know, Google Assistant and other can do? Create tasks, search for things online. The only way to do that is for the model to tell you explicitly, this user asked for this thing. Please, can you perform it on your own so you can implement the logic for these specific things in your applications? So this is the role. This is why we have function calling. And function calling is quite simple. What you need to do is just define some tools. Tools can be get the weather, send a mail, whatever. And to do that, you come here and you create maybe an object called tools. Okay, let's get the official documentation object. Okay, so let me explain this to you. The type is a function, and the function is called send email. Normally in the tool call, you will get this send email to know exactly what the AI asks you to do. And it will be send an email. You give the description so the AI knows, okay, when this happened, I need to call this function. It's send an email to the given recipient and subject and message, okay? And then the parameters is actually what the model will extract from the text and give it to you so you can pass it to your function. So we need the to, the subject, and the body, okay? So with that said, let's change our prompt again, one more time. You're an experienced assistant, you are a helpful assistant, okay? Assistant. And here we'll go back to our normal structure. We don't need this anymore. We just do write an email to Angela at ulife.ai and ask for a voice agent app. Okay. At ulife.ai and ask for a voice agent app. Okay. So now we need something else. We need to pass another parameter to our whole model to say, we actually need you to consider these tools. And the pretty simple things to do here is to pass the tool parameters. It's all tools, and you pass it is equal to tools. Okay. So now you have the choices, and then from the choices, you will see if the function is getting called or not. And this in the message. So if we run this again, oh yes, I think we need to do this and then this as well to avoid issues. Okay, now it takes some time, of course. In the meantime, you will see here that we have past chat completions, and you have a new field called function call, okay, and tool call. Now the tool call will say the to, this is the mail that you need to send to. The object is inquiry about voice AI agent app, and the body is hello, I hope this message finds you well, and everything. So this, you can actually parse this, like parsing it. It's just simple as saying, okay, if this dot tool call. I think it's called tool calls, right? Tool calls, yes, of 0. Dot, what's the name? Function? Yeah, I think it's dot function dot name, if I'm not wrong. No, dot name. Is equal to something. So let's just print this first so we can see if the function name is getting here. Taking some time. It's saying no attribute name. Okay, so we have, where is it again? To subject body, and it ends here from the pass argument. So the name directly comes from tool call here, and it's pass function, and we have function. Okay, that function. Okay, great. You'll see that send email, which is the name of your function here, is sent back by the AI. So you can just create a function called send email. So let's just say def send email. Okay, it takes some params, I don't know, just for clarity, just for, and it does something like print, hey. Okay. And what we have here is, we have this. So what we need to check is if this exists, okay? So if we get the send email at the end as feedback, so we do that function as well, and we check if we get send email. Now what we can do is call our send email function. There's some indentation here. With the parameters, and the parameters here are pretty simple. I think it's called parse argument. So same function.parse arguments. Parsed argument. Okay. So now we try it again. Yes, of course. You wait a minute. Normally this will simulate sending a function, and you'll see it said hey, right? And this hey, where does it come from? From our function. Okay. So we can just be sending an email here, and now you can create complex systems where this AI interact with different other tools. Okay. With that said, let's go to our next part, or the next module, which is actually text-to-speech. The text-to-speech model is actually just made for you to be able to speak. So let's say you're creating a complete assistant, right? So here you need to have a voice reading out of what the AI is giving you back, and you need for that a text-to-speech model. They have a great model. I actually think 11 Lab is better in that sense, but their model is good enough. You will get the voice that you get in ChatGPT. We have all these voices on the website. Let me show it to you. Okay, so let's go back. Done. And we come to platform again. We go to the text-to-speech. You'll see that you have a range of voices here. Hello, hash, coral, you can play and see how they sound. And as I mentioned, the fragment changing is actually this from audio.speech, and you need to know the parameter that you pass to the model. In our case here, the model name, of course, same as before, but now we have two new parameters, which is voice and the text that you're passing. So now you don't pass the text as before, you pass it directly as an input, and you will get back a response, which is an audio in streaming, so you can directly read it when it's coming, or you can save it in a file as the wrote here. So depend on you. So you can use this to actually read things out loud, make your system interactive so you can speak with users easily. Okay. And yeah, the next module here is a speech to text. So this is quite interesting as well, because it can allow you to talk and get the transcription or the translation. Both are great, okay? For the transcription, so first of all, this model is actually open source, so you can just type Whisper, I think it's called Whisper, okay, Whisper GitHub. You come here, you can actually just install it this way. I think this is Whisper 1, if I'm not wrong. Yes, you can just actually install it this way, OpenAI Whisper, and use it like this, you know, without having to pay OpenAI, of course. It's pretty lightweight. You can use it directly into your computer without having to buy a big GPU or something. And when you get it, or if you want to use it with your API, of course, you can do it that way. It's still quite simple. You get the audio, you pass, you know, this trunk again. It's now audio point transcription. You pass the model and the file name. But one interesting use case that they introduced is the possibility for you to give the input text in different languages and get the transcription in English, which is quite important because most of the time your model can perform extremely well in English, but extremely bad in other languages, okay? So you may want to get the output in English so you can feed it to the model and yeah, get better accuracy. So for that, you need the translation module. So here, same thing, exactly. So you just need to change the transcription by translation. And then you give the files, and then now you get the text always in English. If you speak in German, you get it in English. If you speak in other languages, you get it directly in English, okay? So with that said, let's just quickly go through many other API that they provide. The embedding API, we'll go through it later. And I will explain a bit more what embeddings are because this is quite important for retrieval augmented generation. But in general, they have different models here, the small and large. I think they have some legacy as well, legacy models. This just transform your text into vectors like this, so you can do some mathematics operations on it. Yeah, so same, pretty simple, clear and embedding create. As I mentioned, you just need to keep this in mind. This chunk is actually where the use case changes and the input as well. Okay, the text and the model, quite simple. Now, the moderation is something quite interesting as well. So if you create an app where you need to make sure that users not upload some kind of content or hateful speech or whatever, you need to use this here. You can directly do it with the API, like just writing a prompt, do it. But if you want a more moderated, a more specific model to do it from OpenAI, you can use these omni moderation layers, and then you pass the text. It will classify it into Google will. Anyway, you know, all these words that you see on the screen, hate, illicit, and whatever. Now we have some reasoning models as well. So this is a bit more expensive. It's still in beta. If I'm not wrong, the reasoning model are in beta. You can access them, of course, but you need to be in some tier to access this actually O3 mini or other O2 or O1 or O3 mini and others. So yeah, but the thing you need to consider here is that the latency is much. It will be slow, but the output quality will be far more better than a normal chat completion model. Okay, and as you see here, it's actually the same thing. The only thing changing is that you pass the OP3 model and you pass a reasoning effort. Okay. Oh, and by the way, this store just means you want to start it online, and which is quite interesting or important for model distillation and all that we'll see later. Okay. So with that said, we can also go through your image generation API. Where is it? Image generation here. So you can use OpenAI to actually generate images. Pretty simple, you know, image generate. You pass the prompt of what you want and you get an image back. But now we'll go through all of the image generation APIs a bit later. So we'll not be talking about it here. Same for audio generation. So you can actually pass some text and get some audio back. So the model, instead of answering directly with text, it answers directly with audio. Okay, so you can do it here as well. Same. All you need to change is actually give some different modalities here. It's actually the same, and you pass the modality to text and audio. Okay, so with that said, we have some interesting things here. So the predicted output, important when you want to keep your cost low, while doing some things like, you know, code generation or things like that, because you need to feed the text to the model and only just get the completion, which reduces the cost. You can read it more here in this part of the documentation. Now you have the fine-tuning API as well. Quite simple. You create this file with a strict structure like this: role system content this, and then you get the user assistant content this, which will act as a way to steer the tone or the way of behaving of your model. So if you have enough data like this, you can actually make the model be more specific to your use case, or more interesting, or more accurate to when solving problem in your use case. Now the distillation, by the way, just some quick info like this. OpenAI said DeepSeek used distillation in their process. That's the reason why their smaller model is better than O1, maybe. But the distillation means you use the data that a big model generated to train a smaller model, and that will make the smaller model much more performant. At least it can match the performance of the big model in the specific use case that you choose to fine-tune your small model on. So that's the reason why in DeepSeek you have three models. You have the DeepSeek model, the R1, you have the V3 before, and now you have the distilled small models, which kind of have the same accuracy as some of the big models, because it uses the output from the big model. Okay, and to do this in OpenAI, you can directly do it here. You store the data in some specific with some specific data, metadata in the dashboard, and then you use it to fine-tune the model afterward, and use the evaluation metric to evaluate it. So let's talk about evaluations now. Yes, so writing a prompt is interesting, but being able to make sure that your prompt will work in production is really hard. So that's the reason why you have evaluations. Evaluations are like testing in software, where you have to write a test to make sure your software will work properly. For evaluation, you need to have some prompt and some expected output and pass it to the model, and the model will actually compare the real output and the expected output to make sure that it match your expectations. So you have some kind of way to evaluate your prompts, and this API can help you do that. It's still better, of course, but you just go through the API, you click through it, you upload some files, you know, it's you can get it. I just want to mention it, but you can also do it with libraries, with Python libraries. Free to you. You can directly use it do it with the API, with the SDK as well. Free to you. You are free to choose which one suits best your use case. But yeah, you have an evaluation API. You have a batch API as well, when you want to pass multiple things to do at the model at the same time, and this will reduce your costs also. And then you have an explanation about the prompt generation process. Normally in your playground, if you go to playground here, you'll see that here you have some improve the prompt. So they're explaining how they're doing it here with the meta prompt here, saying, okay, this is meta prompt, and then you will get an enhanced prompt at the end, for example. Okay, so you can go through it as well. Everything is in the documentation, but so far what we did were pretty simple, going through everything that OpenAI provide as API. So now let's get into creating our simple chatbot, which will generate UI using, it will generate startup ideas for us. We'll have a UI, we'll be able to chat with the model. It will help us generate ideas and brainstorm. Okay, so let's get started. So now that we have this here, okay, we have all these complex things, function calling and everything. What we need is, let's first just comment a lot, because I will have to push it online so you can have access to it. So just comment it, because we don't need all of these. Okay, same for this. You just need this. Okay, now we just let's just first do a simple chat, and this chat will be called by a Streamlit UI. And to do that, we need to first, as usual, add the Streamlit requirement file here, requirement part here, and do a install requirement.txt again. Okay. Oh, I need to /r here. Okay, so now that this is done, we'll create a simple UI using Streamlit. So let's create a file here called chat.py. And Streamlit is actually just a simple library that will help you create simple testing UI with Python. So what we can do here is just first importing Streamlit, and we need to create a function here. Our function will be def call or just AI, and we pass the messages because we're getting the message directly from Streamlit because we need to display it. And we do what we did here. Quite simple, okay? And then we can give it back, okay? You can just return response or some specific things of response. So now let's design our UI. First, let's import our AI from main, import AI, okay? Now let's set a title to our page, okay, like this. Yes, we need to have a state where we'll be keeping all the messages. So we can do this like this. Yes. Then we need to display the messages. Okay, we can do it like this. We look over all the messages and we display them. Okay. Now we need a prompt where the user will enter the text, and this text will actually call a function. So we do our function, our AI function. We do this first. We type the message will be the input that we have at the bottom of the string, and then here we'll save this into our state, same that we did here in the main. You remember we just pushed okay, I deleted the line, sorry. So normally we were pushing things in this array, so we are doing the same here, pushing things here with the user content, and then we are displaying the user message like this. No, this is too much. Okay, and then now we're expecting the assistant message. Okay, so what we'll be doing is that we'll just create an empty placeholder message, and we need the AI response to be streamed. So we will be having, as usual, full response here as an empty string. I think we did that already, so shouldn't be surprising. Now we do a try and catch, okay? Because it can happen that the model just trash, so we just do try. And then we do except. Okay, and then we paste some, we show some error on the screen. Okay, so now here in this case, in this part here, we need to call our AI, and our AI will be response now is equal to AI, right? And AI gets what? Of course, the array of messages. So we can get it from Streamlit like this. Okay, and we need to display what we got, and we do the same loop that we did before, and we added, we did it already, so we don't need to go through it again. Same, and we add it to the we display the full message at the end, and normally this should be okay, right? We get the response, and we get a chunk in the response, and so now we do here, we do pip install. We did that already, so we just do a streamlit run chat .py. Okay. Yes, so I think this is in the wrong folder again. Yes, so we do this. You will see that it will open a browser. So let me show you the browser. Okay, so the browser is saying, hey, how can I help you today? So we'll say, what can you do? Tuple object has no attribute choice. Okay, so let's go in the code again to debug this. It's saying here that, where is it again? What are we returning? Are we returning the response? Yes, response, we return response as complete. Oh, okay. Yeah, sure. So instead of these, we have something else, which is it's another function. It's chat compilation dot create. Okay. So then we launch our server again. Same. What can you do? Same again. Okay, let me check the code again to see what's happening. So maybe we can write some logs. Okay. Returning response should be fine here. Client chat completions. Let's create. We pass the model for. Oh, we pass the messages. Oh, yes, of course. Makes sense. We need to first activate the stream. Okay. So now when we get this, let's first print response to make sure we get the right response. We get the messages. What's in these messages? Oh, we need to do this like this. Okay. Yes, should be fine. We get your file system. And then this, we don't need this because we are pushing the message directly. So we don't even need these messages here. We are getting it directly from this here. So if we need this, what we need to do is actually get this world here as an array. Put it here in the, where is it again? In our message. Where is it? So here we have something like this. We just do this and we do this. Okay, and we just paste this like this. Okay, so with that said, let's try it again. I think I can watch this if I'm not wrong. I just need to do streamlit one. Okay, so let's run this again. Normally we have a, okay, so let me we have this. So if I say hi, I'll go back to the, we have a stream from OpenAI. Oh, great. How can I assist you today? So what can you do? And you will see that it's writing it directly. This is the streaming part of the thing. So if we remove this, we need to directly get the whole text and show it to the user, and the app is a bit slower. Yeah, so with that said, I think we just have some mismatch here from where we put the user message and where we put the response. Yeah, but in general, that seems good. We have everything. We just needed to update our state. So let's quickly do that. Okay. Like, okay, how can I help you today? I want to start a project. You'll see that great. Passion, expertise, exciting and rewarding venture. Okay. Help monitoring apps, it's giving you some ideas here. Personalized learning platform, AI-driven things. So what else can you do? Idea validation, business model development, market research, this is actually based on the prompt. So, and you can quickly deploy it and show it to people just as a demo. This is not a production ready app, of course. But in general, I think we went through everything. You can actually integrate tool calling, integrate voice, integrate text to speech, and other things. But you have it from the API. You can play around with the version that we have right now. Add more complex things on top of it. If you need more about Streamlit, you can go to Streamlit official website. You have you would get much more information from the app and how to use everything. Okay, you just go to the docs, and you have everything you need here. Okay, how to install it, how to use it, and many more. So if you need some other kind of fields, if you need to build complex app, you actually can do this with Streamlit. So yeah, I think we had a really long video, or long overview of an OpenAI API. Yeah, in the next part of this tutorial, we'll go through the same process. We'll do the same process for Enthropic, so you understand deeply the Enthropic API. you understand how to use the Enthropic API to build complex app. And then we'll do the same for Google, DeepSeek, XAI, and Rock. So if you don't want to miss that, don't forget to subscribe. If you like the video, please just drop a like. And if you have any question, drop a comment. Thank you for watching and see you in the next one. Peace. Hello everyone, welcome back to my channel. Today we'll start the second video of the third module of our AI engineering crash course. We'll be talking about Enthropic API. So we first gave a global introduction of the course in this first module. The second module were about prompt engineering, and then the first video of the third module were about OpenAI API, where we went through every aspect of OpenAI API. Now we'll do the same for Enthropic. We went through everything you need to know to start building with Enthropic, and next time we'll do it for Google, Grok, XAI, and DeepSeek. So let's get started. So the first thing we need to do is to create an Enthropic folder here. We had OpenAI. I think I didn't write it at the right place, so let's do it here. Enthropic. Okay. So in there we need three files. First, the requirements. Requirements.txt. We need the .env, of course, for our env variable, same as OpenAI, and we need the main.py. Okay, so first let's just get in there and create some environment. We get into Enthropic. We do Python. We did this already before, so you just -m vm, and we call it vm, and then we source it, source vm /bin /activate. Okay, so now that we have this, we can put all our requirements here. So let me just add the list of dependencies that we have. We need the .env and we need the Enthropic API. This is the latest version of Enthropic. So to change the version, you need to make sure that the API match what we did in the video before changing this version here. So now we can just do a pip install requirements. So while this is installing, we need a key, and we will call it Enthropic API key. I will show you how to get it in a second. And the simplest way to get it is to come to the Enthropic dashboard. You just go here to the Enthropic API. You can get it by typing Cloud API online. You click on Start Building, and you will get here. And then here you click on Getting your API key, create, you give it a name, and then you have an API key. You copy the API key, you paste it here. You paste it Yes, you paste it in your .env. So now we can start building. Okay, so pretty simple. We need something exactly like this because Enthropic API is really close to OpenAI API. So what we need to change is just here, Enthropic, and same, pretty much the same, Enthropic with the big A. We put it here. We don't need these two modules for the moment. And then here, as you saw it on the file, it's called Enthropic under .env. Okay. With this here, now we can start working on a client. Okay, but before that, we need I need to explain some few things to you. So let's just first start with chat completion. And for chat completion, we need something pretty similar to what we did with ChatGPT. So let me just comment it. You can see we need an array of messages with a system prompt. I will show you how to put the system prompt in Claude. With a model, with messages, it's pretty close. I think they got the inspiration from OpenAI because they are the first doing it. So you will see that the API are actually quite close. So let me give you a quick example here. We have messages from there. So I will show you where to put this. So this is how you do it in OpenAI. So I will just show you the difference. So here we call response is equal to client dot messages dot create, and then here we need some few parameters. The first parameter is the model. So we just put this. Then we need max token. Max token is the maximum amount of token that you get back from the model. And then we need messages. Okay.
So this is different in Claude. This is how we do it in OpenAI, but with Claude, this, instead of being here, it's actually down there, like this. System is equal to this, and you remove this part here. Okay, I think you need just a comma here. And then, as we already installed our packages, all we need to do is run this file. Let's print the response. And then we do Python man.py. Take some time. So we have some issues saying that not found model Claude 3.5 Sonnet. Okay, so we need a specific version of this model then. So let me just get it. Okay. So run it again. As you can see here, we get a response in some weird language, but yeah. So we get a response here. And same as with ChatGPT, we have only here the possibility, only this system prompt gives us the possibility to actually change the whole logic of our AI application. So let's say we want a, I don't know, a meme generator or some kind of joke generator. So we'll change it here. You are a joke generator, and you can generate funny jokes. Okay, I think it's funny here. And here you can just say, hey, tell me a joke about Europe. It will surely be a bad joke, but let's try it out. So here you can see that from this table here we have content, which is an array, so we can do that content, and then we have message somewhere here, right? Text, sorry. So we just do that content of 0 dot text. So save this, we run this again. Yep. Why are Europeans such amazing storytellers? Because they've got so many tales from the dark age. What do you call a French person holding a piece of cheese? A brilliant European. Okay. Don't know if that's funny, but at least you get it. You can change the system prompt here and get a completely different app, same as with ChatGPT. So now let me give you a new thing, which is system prompt caching, or just prompt caching in general. So here, let's say you have a really long app and the prompt is like burning $0.5 every single time. You have one way with Enthropic to actually avoid that. And that way is called function prompt caching, sorry. And the way you do it is quite simple. You just change the system prompt. Instead of having it as a string, you have it as an array of objects. So let me just give you an example. So put an object here called type text. So same here, like this. Okay, then you have the text itself, which is your system prompt, like joke, tell jokes. And then you have a third parameter. This third parameter is actually where you control the cache and the prompting. So you have this cache control, where you type, I think the only type existing right now is ephemeral, where you actually mention to the AI that it should keep this in the cache for a certain amount of time. I think it's 5 minutes for a moment, and then it will help you reduce your cost. And based on the finding from Enthropic, it can reduce your cost from $3 to $0.3, around nearly 90%. So it can be quite interesting if you have really long system prompt. Okay, so with that said, we can go back to our original one, because I want to show you how to do the calls with PDFs. Okay, so we get this. From here, what we need to do is to create a file as usual, and this file will be passing it and changing it into base64. And to do that, we can have here an example straight from Enthropic with the URL of the PDF here. Okay, one of the Enthropic PDFs, and then you have the transformation into base64, but we need to first import the necessary packages here, and we are using HTTPX as well, so we import this as well here. Okay, so what's happening here is that we have this URL, we pass it in base64, we did the same with vision model from OpenAI, and then now we can pass it to the model. So what it does is that it just transforms this file into a string that you can pass through the network. Okay, so here in the messages, what you can do is to just add a field with the role user, with the type document. Where is it? Here. Okay, and then here you will have content document, type document, and then type base64, the type and the data, which is actually the base64 encoded version of the PDF. And this is quite interesting. This is for citation. So if we remove this, we will not get any citation. You will see that later. And then here is the next part where you get a question. You ask a question about your document. Okay, so we can even comment this because I need it at the moment. It's not mandatory to have the system prompt here. So if we run this again, you'll see that it's taking some time. And this time it's actually figuring out how to extract key information from the document and send it back to you. And you will see the response still coming. Okay, so you can see here that the document emphasizes Enthropic commitment to responsible AI. It's actually a model card, so it's actually about Claude 3, and the document had all the information about in a Claude. So now if we add this again, okay, you will see that this will change. You will get the same response, but you have in the metadata the citations. Instead of only text, you can see also citations. So but for that we need to change our code a bit to do something like this. We just print the response, so you see the whole data structure. So we'll just get the response for the moment, but yeah, after the response I will run it again so you can see it with the metadata and the citations and see how it works. So let me this is actually interesting. Why? Because this is first part of the text, and it will be giving you chunk by chunk with the citations if it finds it. So this will surely have no citation, maybe, and then try it out again. You'll see from the response. So each chunk will tell you if there's a citation to it and give you the information about the citation, so you can add it directly right after your text. So maybe this part you will not have to put a citation incurred for it, but the other part that the model will give you, you'll just put a citation incurred for it directly coming from the model. With the text also, you can highlight it in your document if you want to. So okay, while waiting, let's see what we'll be doing next. The next topic we'll be talking about is actually, okay, maybe in the meantime, yes, we get the response here. Here, so you can see that we have much more here than what we got at the beginning, right? This was pretty simple, one single element, but with citation none, you can see it from here already. But if you come here, you'll see that some sections have no citation, which has no citation. Some sections have no citation, which is pretty normal. But now, if you go a bit down, you will see somewhere, just search for it, citation, none. But here we have a citation, and the cited text is right here. So you can take it and highlight it in the PDF, search and highlight in the PDF with the text alongside it. Okay, same when you don't get a citation, you get none, and when you get a citation, you get this. Okay, so yeah, so that's good about citations and text compilations and changing use cases. And as I mentioned, use cases all only here in the system prompt. So now I wanted to introduce some things to you, some things from Enthropic, especially concerning the prompting techniques that they have. So if you go to your documentation, so let me just go to the documentation and show it to you. I think here, developer docs, you will see that you can search here for prompt, and you will see different things here. The prompt generator. This prompt generator is actually Google Colab. You can see it somewhere here that you can run with a meta prompt as well, exactly as on ChatGPT. We did that already with the meta prompt. and the meta prompt will be generating prompt. But here it's actually based on the task. It's not improving the prompt, it's generating it. So you have something here with the task instruction here. I will tell you why you're using XML. It's actually mentioned in there, and you will replace this task with the task that you have. So that you will mention, and you will see down there, this is a really long meta prompt that we are replacing. What is it? We have a task here, we have an email responding to something, and then somewhere here we're replacing the task, right? In the meta prompt. And then yeah, we're getting a better prompt out of this. So this is you can use this to generate better prompts for Enthropic especially. And you can see somewhere here that they are talking about using XML tags. So according to them, it helped the model give increase its accuracy when you use XML tags. So instead of just maybe doing like roll 2 dots and then you start writing, you can just wrap it into some XML like this, like instruction, example, formatting. Same for the chain of thought. We'll come to it later. And it will help the model actually give you better understand the structure of your prompt. Same for the response. You can ask the model to generate some part of the code in some XML. It can be maybe, text compilation, like in bold.new, for example, you have two different sections. You have the code section and the explanation section, and you can parse that and display it in 2 different windows, or actually write the code in a file and display the text in the chat box, right? So this is quite interesting. And yeah, apart from that, we also have the chain of thought here. And the chain of thought, as you mentioned somewhere here, you need to use some XML with thinking here. Okay, use XML like thinking and answer. I think we talk about chain of thought. If you didn't watch it, I'll put the link to the playlist in the description, and you will see it in the prompting guide. Yes, so basically you can implement it here. Same for the prompt improver. It's just a way to improve your prompts if you already have a prompt. And then we have some simple security things here based on your prompts, like avoiding being prompt injections and avoiding leaking your prompts. I think it should be somewhere here. Oh, and they have some example of multi-shot prompting as well. So the prompting guide from Enthropic is actually quite complete, I would say. So in the meantime, let me just look for it somewhere here. Should be. Let me search for it. Jailbreaking. Okay, here we go. You can mitigate jailbreaks and prompting injection. So this is some security content, and we'll talk about it in depth in the upcoming sections of the course. But in general, you can read this to have a bit more of a view and how to reduce your prompt being leaked. But here they are saying you need to do it when it's really, really necessary, right? Because what you're implementing here can increase the complexity of your prompts, or what you're doing. But in any case, the results are actually quite good here. Same for reducing hallucinations. You can just say to the model things like, I don't know. But in any case, you have the resources here. You have the prompting module to understand a bit more about prompting techniques. And then from that, we need to move to the next module of this course, the next part of this tutorial. Let me go back to my code. And this next part is actually function calling. So we saw with ChatGPT or OpenAI, we saw with the OpenAI API that if you need to do a complete system that call external resources, you need function calling, because what the model is giving to you is actually only compilations. If you ask for something, you get the text back. But if you want to know, how do I get the weather? How do I play a song on Spotify? How do I do specific things? You need function calling. And function calling is actually part of the Enthropic. It's supported by Enthropic actually. So I will show you how it works. And it's called tool use. So what we do is actually pretty close to what we had with ChatGPT. I think we can get the same example actually, if we still have it. I think we had a tool here, okay? Tools. And we add it at the top here like this, okay? We just, okay, uncomment this. Yes, so what we need to change, we just need to change some few things. We can give a name to our function. So instead of having type and functions here, we delete this like this and straight through. Should be fine. Okay, we have a name, we have a description, we have the instead of parameter, we call it input schema. Okay, we have a type object, the properties, and the properties is actually what we are giving to the model. So here we have a tool, we have a type, string, we have a description, same. And if we have some required parameter, we can actually give them to an array here called required. It's actually pretty much the same thing. Yes, so with that, you will get the response with the tool calling actually. So let me just remove our message here and come back to a base message with the content being just hi or something like that. I think from ChatGPT we had a really interesting prompt. Let me just close this. Send a mail to contact@ulive.ai to ask for a voice AI assistant service. Okay, so this will actually trigger a text that will give us this send email and the parameter that are extracted from this text here. So let's try it out. I think we're prompting message response. Great. And I forgot to add it to the, I need to add tools here. Okay, and then it got it. We don't have any document anymore. Yes, okay, so we can delete the document part. Yes, okay, so we try it out. So see here, I'll help you send an email, but if you see tool use block, you'll see that you have an input, the subject, the parameter that you needed, and you will find the name of the function that's supposed to be called here. And you can just pass it the same way we did with OpenAI. Let me show you if I still have it here. If response gets the function with name send email, we call the send email function with the parameters. So it's actually quite the same thing. It's pretty close. So when you know exactly how OpenAI, I forgot to mention that this is pretty important. When you know how the OpenAI API works, you can work with almost every provider except Google because they want to do the things their ways. But almost all these providers are pretty close, and a lot of them actually support the format of OpenAI. We'll talk about it when we talk about Grok, DeepSeek, and XAI. So far, this is how you do function calling in Enthropic. And so our next topic will be a bit more general things like embeddings, NPC, computer use, and more, which are API that you can use. But you can see here something about embeddings. Same, they have 3 models as OpenAI. Oh no, more models here, six models, I think 5 to 6 models that you can use for embedding with the embedding dimension here. Same process. Instead of just saying how is it called, model.create something, I think they have a, let me see, a voyage API here. Where is it? Where you need a voyage API key, you get it, you install the package, you embed the model, and it will directly embed into your Voyage AI platform. So what you can do is just pass the model here. As you can see, you have a list of models here, Voyage 3, Voyage Lite, and it will give you back the embeddings, as you can see here, which is actually just an array representing the text. Okay, so same here for some add-ons. This is just manual add-on so you can use in same here for some NPC. So this is used to add tool support to Claude, so Claude can call this tool. So if you want to learn more about it, there's a complete website here. You can implement them with Python. You have pretty great tutorial about it online. But I think it's not part of this course. Same for computer use. I think we talk about prompt caching, PDF support. Mrs. Batches is actually pretty simple. I think we need to talk about moderation as well. So moderation here in OpenAI, we saw that you can do moderation with their model, a specific model that they built for it. But here you need a prompt, and the prompt is actually here. Where is it again? Here, okay? You can see it here. Prompt determine this, and respond with this. So you need to build it yourself. So there's no specific model that can do that. But in this case, we are lucky enough, you get a really small model and it can do this classification for you because it's a pretty basic task, right? So you don't need to spend a lot of money on a big model. You can do it on the lower cost model here. So if you want to do moderation with Enthropic, here you go. You have the link here. I just read a bit through it. You copy the prompt. Same. We can directly do it even now. Copying this prompt, pasting it into our prompt part, and then running it with some examples. Okay. So with that said, I think we basically did everything we needed to do for Enthropic. And also, this is where you actually get real curl call when you have a new language instead of Python or JavaScript. And if you're working with JavaScript, you also get the documentation for JavaScript here. You can directly use this and format your call in your programming language with this call process here. So when you just get the URL, the API key, the version, the content type, you can directly set it up in any language using just HTTP packages, okay? And yeah, you have the API documentation here with an example and an explanation of why you need each parameter. Okay, so here, for example, you have messages, you have assistant and user, you have everything you need to build this fully functional system with Enthropic, any fully functional system with Enthropic. Yeah, so with that said, I think we went through everything we need to do for Enthropic. If you need more information, I'll put the link to the documentation in the comment below. In the next part, we'll talk about Google and then other providers and then frameworks. So if you don't want to miss that, don't forget to subscribe. Thank you for watching and see you in the next one.
Hello everyone, welcome back to the third module of our AI engineering crash course. In this video, we'll talk about Google API. So we'll go through everything Google has to offer, and including the new model, the OpenAI integration, and all of the possibilities that you have with your model. So right before, in the first two modules, we talk about AI and AI engineering in general in the introduction module, and then we went through prompt engineering. And for the third module, we talked about OpenAI, Enthropic, and now we're talking about Google. In the next videos, we'll talk about Grok, XAI, DeepSeek, open source frameworks, or open source model hosting platforms, as well as frameworks. So let's get started. So as you can see here, we still have the Enthropic and OpenAI folder. So let's just close this terminal. We need to create a new folder for Google. So let's call it Gemini. Okay. So in this, we, as usual, need the requirements of txt, the .env, and the main.py. Okay. With that, we just need to come here in our .env, create a Google API key, which is an empty string for the moment. And then we open a new terminal. Okay. We go into Gemini. Then, as usual, we need to create a virtual env. So we do Python env, venv. Then we do source venv/bin/activate to activate our virtual environment. We get it here now. And then we need to put all our requirements here. We basically have the same thing. Just take this, put it here, but we need to change this line here. And we need the new Google API. So let me grab it quickly. Yes, so we have it here. We just need this here. And then we install our packages. So Python, pip install requirements. Okay, so when it's downloading the requirements, we can come in here we need to put our API key here. Let me show you how to get your API key. So it's pretty simple. We come to AI Studio. You will find this Google Studio. And here you have this simple button here, get API key, and then create. It's actually in French, but the button will be the same, create an API key. So it takes some time to create the key. And then we click on copy, close this. Then we paste it here. Okay, this is our key. Now here, we need to do different things, okay? The first thing I need to show you here is how you can use Google without changing a lot in your code. So if you're working with OpenAI, we did a really long video about OpenAI. You will find the link in the playlist in the description. And you know and love the OpenAI API, you can use it completely from scratch by changing few lines to get everything that you have from Google from the OpenAI API. Same for other providers. So what we need to do is what you see here, this initialization, actually the same code. Everything we did here is actually possible with Google. Okay, so let me just show you this. By the way, to do that, I forgot we need the OpenAI requirements here as well, the version and the package. So we need to add it here and start the requirements again. We'll directly get it from cache, I think. Okay. So here, you will see that we need to change few things here. The first thing is this key. Instead of the OpenAI API key, we need I think I call it Google, right? Google API key. So we change it here first. And you need to pass more variables. There's a variable called base URL. And this base URL will be pointing to Google. So we just say this. This means every request going through the OpenAI API here will be heading to this endpoint here. And this endpoint is actually from Google. So they have this beta support for OpenAI for you to be able to switch from OpenAI to Google by changing only here, which means everything you did or you completed with OpenAI, you can do basically the same with Google. So let me show you how. Okay, let me give you a quick example. Let's grab an example from here. As you can see here, copy it from the OpenAI code and we paste it here. Okay. We have the model, but this model here need to change because Google do not have a GPT-4o. Google has Gemini. We can have the 1.5 or the 2.0. We can just put the 1.5 here. And yeah, with that said, we have the system and we can directly add the user per part here. Tell me more about you. Okay, so if we save this and we print the response, we clear this and we do Python main.py. Oh yeah, for comma. I hope I did. Okay, great. So we do it again. And you will magically see that we get directly a response. But if you read it, it will say here, I am a large language model trained by Google. And what's funny is that we're using the OpenAI API, right? So this is quite powerful. If you want to switch between different models, you just need to switch the base URL and you will see how this is extremely used in the industry in the next video. But for now, we have this. You can do function calling and many, many other things that you do with OpenAI directly with Google, and they are fully supported. Yes, so as you can see here, to get this, we need to just go to choices, the index 0, and then message, and then content. We get exactly our message. Yeah, and you can basically do a lot of things with it. Almost everything you do with OpenAI, simple text generation API, chat API, Yeah, but I will also show you a second way of doing things, which is actually working with the Gemini API directly. We have much more powerful feature that OpenAI does not support that we can do with the Gemini API. So let's delete everything here and create a new client. So we first remove this because I need this. We need to from Google Gen AI. And then for the client, we just need something like this. We load the env, and then here we do os.environment of Google API key. Okay. Now we can use this client to ask things to the model. But what is pretty weird is that for Google, for the Google-based API, you have something that's quite different from other providers. You will see that Enthropic is quite close to OpenAI, same for Drog, XAI, and DeepSeek. But the Google client is quite different. I think the reason is that Google released their model and their API between the same time. They couldn't follow the OpenAI specification or the OpenAI way of doing things at that moment. So they created something completely different. And now they're trying to get back to it by using the method that I showed earlier. But now your way to generate this is actually to just, let me just show you, use this, for example, we'll use the latest model, the Gemini 2.0 Flash. Seems to be less expensive. And we just say, tell me more about you. So here's the model as usual. And this content here, it is quite, I don't know how to say that. You will see that with other models, you need to pass an array of conversations somehow. But here you have the generate content. This generate content is not a chat model. It is a completion model. I will go through the chat model a bit later, but you directly pass the question or the user input here, and you'll get a response based on that. So let me just print the response. Clear. Taking some time, and you see we get something a bit different here. So we have candidates, we have content, and in content we have, if we get a video, if we get code execution, and we'll see that in the upcoming part of this video. But here you have text, and this text is actually a large language model trained by Google. Same thing, just that in this part of the code, we actually used the base Google API. Okay, so now we can do many other things with this. So here you saw a completion model. It's just completing text. And then now if you want to do a chat, you need to change the way you call the model. So here you will see instead of client.model, you instead use client.chat, and instead of generate content, you will use create. So let me show you that. So what you need to do is create a chat model. When you have the Gen AI, you delete this like this, and you paste this. Okay, chat is equal to client.chat.create. Just create a new chat, and you will see that the way Google did it is quite interesting because they help you a lot with processing an array of conversations and things, but it's also drawback because you will not support or you will not have the flexibility to deal with which content, which context you passed to the model. But let me show you how. You come here and you just ask something like this. So response is equal to chat.send message. Okay. So this is you sending some message to the model. It can be, hey, what's up? And then you get the response and you send another message. You will see that with Google, the structure is quite different. With others, you need to keep an array with user, role, assistant, and other. But here, you print the response. response.text, and you can directly ask something else like, okay, tell me more about you now. Like, tell me more. Let's say, how can I Google something like that? Of course, you shouldn't do this, but just for the sake of the tutorial, let's try it. And you will see now that, and if I say my channel is Altifin, let's say add something else here. And what is my channel name? Okay. You will see that it's taking the context from up there. You'll understand that it's actually getting the conversation from the last message. So let's save this, try it again. Okay, you see here. So you are Altifin on YouTube or another platform, or like YouTube, and then your channel name is Altifin. You'll see that the first message has been sent to the model and kept by Google, okay, for this conversation. And when you send the second one, the context from the last conversation is actually automatically added to your conversation. So you have recurrent caching of the conversation. So you don't have to send array over and over again. I think that's quite interesting. Could have been great as a standard, but it's a bit less flexible for you as a developer. So now you can look through the chat history and print it or something like that. To do that, you need to come here and do for message in the chat dot curated history. You can directly print maybe message dot cards text. Okay, it will print all the messages that we have in the conversation. So maybe I need to, yeah, should be fine. If we try this again, let's first, okay, if we try this again. Okay, you'll see that here. Maybe I need some printing or something. Okay, you'll see that it's saying hey there, and then hey there twice, and then your channel is, and your channel is, okay? So you can actually get access to your history as well, and print it if you want to. And if you see here, for example, it's saying, hey, what's my channel name? Which is my question here. You can actually get the role as well. It's pretty simple. It's just message.role, like this, message.role, okay? Yes, so this is the way you actually create a chat model with the Google API. Okay, so with that, you may be asking yourself, where do we actually provide the system prompt? Because so far we just made a conversation. We didn't direct the model to do something, okay? And to do that, we have a key parameter that we pass to the generate content. So let me show you. Let me go back to the other model. We can do it directly here as well, like this. Pass a comma here, and then we pass config. This config help a lot with many things, but let's start with types that generate. Generate. Content config. And then what we need to pass is here system instruction is equal to. Now we can directly pass the system instruction. It can be you funny, only make jokes. Okay, so now if you come back here, let's say we delete this part, we just need the first message, and then we run this again. Yes, of course, I forgot to import. So we need to do here from google.geni import types. Okay, and try this. Okay, elephants look like a brand of vitamin C designed to help you procrastinate, take one. Anyway, some kind of job. And you can see that you can change it here directly with the system prompt. Okay, so with that said, let me quickly show you something as well. It is your capability to directly get this chat model and actually stream the response. To do that, instead of send message, you call a function called send message stream. And to handle it, you will get here some chunks and you just need to do a for loop. Same for as with OpenAI, chunk in response. And then you will do some chunk dot text here. Okay, and it will show you the chunk. So let me just quickly show you here. You see that it's giving it chunk by chunk, right? Okay, so I think we can also pass a temperature here if we want to. And for that, we need to come to the generative config here. And here, as I mentioned, I think from the introduction, I'll talk about the temperature and why it's important. So once again, the link to the playlist in the description. What you do here is just put temperature to control the randomness of the model. Okay, our temperature is equal to 0.9 maybe. And you can also pass a maxed output token. It's equal to this, for example. Okay. Oh, not taking into account this 0.1 and max output tokens is equal to this. Okay, so this will actually give you the same result, but it will be less random when you run it multiple times. It will be more deterministic, and here it will limit the return output to this size here. Okay, so I think we went through the basic of the completion model and the chat model. So now let me show you something pretty interesting from Google. So sometimes you may have use cases where the output needs to be accurate and you may need to execute some code to actually calculate something. So for example, let's say you want exponential of 500, right? Python will do it quite well, but the AI itself may struggle to do that. Google have Google came up with some concept called code execution that lets you prompt the model to execute some code if you ask for some instruction that needs maybe veracity or that can be computed with the code. So let me show you how. It's just actually a tool that you add to your to this config here. You have type generate content config, and here we pass a parameter called tools. We'll use the same letter for function calling. So this is kind of function calling, type those tool, and we pass here code execution is equal to types dot tool code execution. Okay, so what will this do if you just say here what is exponential of, I don't know if that's too much, factorial, that's too much. Let's say this maybe. Okay, and then here we don't stream the response, we just get the response. We don't need to stream it. We get directly here response. Okay, and then let's run this and match this. Okay, I think we had some issue here. Okay, we have a trading comma somewhere. By the way, this is quite expensive because it needs to run sometimes multiple iteration to get the right answer. So use it only when you need it. Okay. Yeah. With that said, let me see. I think we had an issue somewhere. Okay. Yes. I think here we need models generate content, and we pass the model. Okay. We pass the configurations. Okay, and then we call it chat.send. No, we don't need the chat.send anymore because we are not in the chat model, so we can directly get it here. So we can call this response. Oh, okay. Oh, yeah. Sorry, I don't know how it went there. It's pretty hard to debug. Okay, so it's saying client.generate content. Missing one required parameter called contents. Yes. We need content here. Okay. Almost forgot. So we just say you are market expert. We can okay, and then we pass this here as contents. Then we wait. Okay, so you will see here that we have a code execution result. Okay, this code execution result gave us an output, and this output is pretty long. So it used code to actually calculate that. And what's quite interesting is that if we come here, you will see that it used Python. Okay, and you have the code that has been called here. Import math factorial this, go to this, and print factorial this. So you can actually print what you get from the code execution part, and which is quite interesting if you want to do things that requires your model to make accurate calculations or execute code on the fly. You can use a code execution tool from Google. Yes, so now we talk about chats. We need to talk about document support. We saw that only OpenAI do not support document support. Enthropic supports document. And Google also supports documents, and that's quite simple. I just say PDF file is equal to, let me check some PDF online. I think we can use the Enthropic PDF link. Where is it again? Assets, this, Cloud 3. Okay, great. We just paste it here. Okay. And then what we need to do is either we get the content with HTTPX. So for that we say doc is equal to HTTPX, and we need to import that. That get PDF file that content, and we import HTTPX. Yes. Okay, and now we need to come here in the content part. Instead of passing this, we pass an array, and then here you will have this type like this, where this is actually our doc that we have here. Okay, this is the type application PDF, and we need the last part, which is actually a question, and the question will be, let's say, which model has the highest win rate? Use case here. Okay, so we can delete this config here. We don't need it. We just need this. Okay, I think we're printing the response. Fine. So let's run it. Okay, you'll see that here we have document Claude 3.5 Sonnet. You'll see that this is actually coming from, you don't see any Claude here. So it's actually coming from the Claude document here, the Enthropic document here. So the model is actually able to get a PDF directly and extract key information from this PDF. Okay, and what you have with Google that you don't have with other providers is the context window. You can pass documents that are extremely large. This document is actually pretty simple. You can pass like 90 pages documents because they have 1 million max context windows length. So you can pretty much work with really large documents and directly get them into your model and maybe chat with the document directly. With that said, we need to talk about some generic things. But before that, we need to talk about function calling. The way Google do function calling is quite different as well. And I would say it's original and good. Same for the chat, history. So the way you do that is that you define the function. Okay, let's say def play Spotify song title. You need to pass types here. So string, and it returns string. I don't know. Okay. Then now we just print I am playing song title. Okay. And return this. So the way you do it is quite simple. You come here in your model, and this config is actually the key. So we can comment this and comment this part. We don't need it anymore. We'll need it later. We have the model, of course. And for that, instead of this, what we need is something like this, okay? And here we have a key called tools, where we can pass an array of functions. Here we'll call play Spotify, okay? And then we have another parameter called automatic function calling that we can disable or enable. The name is quite explicit. Yeah. And then tool config, okay? Here, where we have the tool config, okay? Function calling config mode any. So this actually forces the model to call functions instead of chatting, okay? So if you ask now in the content, play, I don't know, play Kendrick, not like us. Okay, we have, yes, oh, forgot. Okay, modulating record to and unexpected content, where is it? It's content. Automatic function calling disabled is set to true, but automatic function maximum mode is set to be a positive number 10. If you want to enable, okay. But anyway, you'll see here that we have a name, place 45, and a function, place 45, where is it? With the song Not Like Us. So we'll call that function with the song Not Like Us. And if you see what we did with OpenAI, we had to clearly define the function and the arguments, but here we just directly pass a function, and Google will extract the key information that you can pass to the function and execute. So that's quite interesting compared to how other models actually do function calling. What is also interesting is that you're not limited to only doing this kind of function calling. You can call other functions from Google, like the Google search tool. And that's pretty interesting if you want to get a reference from what you're doing. So, and for that, we need the tools again, but but not this kind of tool. So we need to go back to the way we did tools before here. Okay, so it's this generate content and tools here, tools, and then here we call it Google search. It's type.google search referral. Okay, so you come here, you run it. String. Okay, I think I made a mistake here. We don't need it anymore. So let's delete this, and then should be fine. I think we don't have content. Yeah, we need contents. how compare OpenAI and Google and Gemini. Okay. Okay. So you can see here that we have some kind of HTML and some kind of web page from the suggestion from Google, but the result is actually quite far. But you will see that a huge part of this actually comes from Google, and you will have the reference for it. Let me show you here. You see it? This here. Grounding metadata. You have the vertex. This link here. You have many links actually as reference for your search, which is something that's quite interesting when you want to get information directly from Google to use in your app. Okay, so I think with that we went through everything we can do with Google. We have other things that we can actually do, but you can directly see it in the documentation. So maybe I'll put the link in the description. But in general, the essential topic we discussed already. Yeah, so I think so far we went through everything. Function calling, Google search, context window, prompting, chat, text compilation. Yeah, I think it was everything. So yeah, so I think we will close the tutorial here, and yeah, I will see you in the next part where we'll talk about Grok, XAI, and DeepSeek. Thank you for watching, and see you in the next one. Ciao. Hello everyone, welcome back to my channel. Today we'll continue our AI engineering crash course, and we'll talk about a lot of providers. We'll talk about Grok, XAI, DeepSeek, Together, OpenRouter, and one outlier, which is a replicate. And we'll be just giving you an overview of them, how to use these providers, because they have one thing in common. They are extremely easy to integrate when you know OpenAI API. So let's get started. So we went to the introduction and prompt engineering already. And in this third module, we talked about OpenAI first, which is really crucial for this video. So you need to watch that first. I'll put the link in the description below. We went through the Enthropic API, the Google API, and then we'll do the rest of the providers in this video. So let's first start by presenting these providers. We see here XAI. What is XAI? XAI is a company created by Elon Musk, extremely linked to Twitter, and releasing models. I think last year, their more than 300 billions model were actually open sourced, so you can use it for free. And I think it's extremely trained on Twitter data, so it can be biased a bit, but the model is good enough to be used in production for specific use cases. So with the tool I'll be presenting later, you will see how to host this kind of model yourself, and also how to use them in your application. Same for DeepSeek. I think DeepSeek, you heard about DeepSeek recently. They built a model called L1 that allegedly beats O1, or actually is on par with O1 on many benchmarks. It's actually from China, and it's also open source. For the moment, it is the best open source model, so you can also host it and use it yourself. And Grok is actually a hosting infrastructure, and it helps you run open source model, but extremely fast. So I will be giving you some overview at the end of these platforms with your website. But what they're doing is actually helping you run this model at a really low latency. So you can use them for apps that needs real-time data, maybe for voice AI applications where you need the text generated by the AI quickly. So Grok will be a good provider for that. So here we have Together, OpenRouter, and Replicate. So this actually hosting platform. So when you have this Grok, when you have DeepSeek, XAI, and other Llama, Mistral, and all these open source model, you can host on Grok or Together, or Open Router, or Replicate. So they make it extremely easy to choose in host model. You just click through 3-5 clicks and you have a model hosted on a shared environment, and you have the access through an API. And the way to access all these models on all these platforms except Replicate is quite simple. You just change one line in your code. And this one line is here, the base URL. I think we introduced it in the Google video. Google also support that to change the OpenAI API to match a specific API from a specific provider. All you need to change is your environment variables that you will get from all these platforms. You will get one API key from XAI or DeepSeek or Grok or OpenRouter, and you will actually put it here. Same for Together, and then you will just change the base URL with one of these, depending on the provider you're trying to use. So if you want to use directly the API from their platform, you can. If you want to host one of these model yourself, you can use OpenRouter or Together or Replicate, and have and they will give you an API like this, where you can actually, that will help you access the model. Okay, so with that said, let me show you quickly the website of this provider. So you can see here together.ai. So if you come to their main website, this is the documentation. They can help you host a lot of models. So if you come to the main website here, you'll see that it's actually a hosting platform for inference to fine-tune and run your model. So you can actually fine-tune on together.ai and also host models there. So it's pretty simple. You create an account, you choose model, click on host. You choose if you want a specific environment for yourself or just want to host it generally, and you get access to the API using the method I showed you, which is also here in the documentation. So you import OpenAI, you pass the API key from Together, and you pass the base URL, and you use it exactly as you will do with OpenAI. Same for OpenRouter. So if you come here, same base URL, OpenRouter key, and yeah, you have everything you need. So we can also access the OpenRouter platform here, and you will see unified LLM for interface for LLM. And you need also to consider the price, because each of these provider have a specific pricing. I think you can see the pricing here. You'll see it somewhere here. Specific for models, Llama. This is the pricing for 8B until 405. Same for DeepSeek models that you can host here as well. Seem more expensive here than on your platform. Here, same. Okay. Now XAI is actually, as you can see, company from Google, from Twitter, and from Elon Musk, and you can do many things with it, including image generation. But they also have open source models. DeepSeek, and I think you know DeepSeek already, the Chinese platform. That's actually here, DeepSeek V3, and you can see the L1 somewhere here. Supposedly beating O1 Mini in different benchmark. And the good thing here is it has reasoning capabilities, but it's really slow. So if you want the model to think and give you a response, you will have to trade the latency for that, to trade the time that the user will wait for a response in your system. And Grok here, you can see how fast Grok is here based on benchmark. You can see Together and other hosting providers. You can also check them out, but they are actually pretty fast. So they have a really simple example here where you will see, let me show you, you'll see how fast this is. This is extremely fast, 750 tokens per second. As you can see here, almost 750 tokens per second. So it's good for use cases where you have you need to have things pretty quickly. Okay. Now for Replicate, you have a specific API here. With your SDK, you use the model that you want. I think you have a list of models that you can use here. It can be visual model. It can be so you just come to one of these models. You can fine-tune directly the model on the platform and also host it. So you have the pricing here as well. So yeah, to see the infrastructure you'll be renting to do your fine-tuning or your inference. So as you can see here, you have their SDK, and you will need to go to your documentation to see how to use your platform efficiently. Okay. Yes, so with that said, I think we went through everything. All of these providers, except Replicate, have one thing in common. You can switch between different providers only with one link and one API key. So yeah, I think that's all for this video. Thank you for watching and see you in the next one. Everyone, welcome back to our AI engineering crash course. In this video, we'll talk about LLM frameworks. Just as a recap, we talk about AI engineering in the first module. We talk about prompt in the second module, and this is the third module where we talk about APIs in general. We went through the OpenAI API, the Enthropic API, Google, Drag, XAI, DeepSeek, and some hosting providers like Together, OpenRouter, and Replicate. In this video, we'll talk about frameworks like langchain, Haystack, and LlamaIndex. So I will be giving you an overview of these frameworks with some small sample code so you see how you work with them. But most of these frameworks are made for retrieval augmented generation, which is our next module. So what will happen is that I will be giving you a real project using one or two of these frameworks in this section or in this module, where I will first explain some high-level concept to you before going through a real project. Otherwise, if we do it here, you will have a lot of knowledge that you will not, there's a lot of concept that we will not grab directly that we will first need to explain here before we start working with retrieval augmented generation. So let's get started. As you see here, we have a simple static row with each of these provider, each of this framework. So we can go through everything they're offering and how you can take advantage of this framework. So let's first start by langchain. Langchain is actually an ecosystem of tools that you can merge together to create an application. It's one of the first LLM framework, and it was built to abstract the LLM logic from the application, so you can easily switch between providers, easily adapt to many different APIs without having to rely on each API specification. Today, a lot of these API providers actually support OpenAI. It wasn't the case before. But even with that, as you saw it last time, function calling can be different from provider to providers. Same for how you actually do some few things. And if you really want to support all of these providers and be flexible enough in your code, langchain, Haystack, and LlamaIndex can be really helpful. Same for having an ecosystem of complete tools, so you don't have to code everything from scratch. For example, PDF loaders, vector store connectors, and many other things that we'll see in the next part of this video. So let's first start by giving you some overview of all of the langchain ecosystem. The first thing is prompts. Langchain gives you an easy way to work with prompts. It can be with templates, templating engine for your prompting, so you can directly write a prompt with some variables that you can use later. And it also offers you a prompt hub, so you can pull prompts from people from the community. If you don't know how to write good prompt, you can actually just search there. If you find a good prompt matching your use case, you can directly use it. So let me just give you langchain herb. If you go in langchain herb here, you will see that you have a lot of prompts. So maybe you can just pick one. Rack prompt, super agent, React. I think we talk about React in the prompting part. Yes, so you can just choose here from the hub the prompt that suits your case, and directly integrate it into your code. Otherwise, we have the vector store. That is a concept that we'll talk about in the rack module. So subscribe to see that video coming next time. You have the document loader, the text splitter, also concept that we'll be explaining in the rack module. But in general, they actually use to work with documents and to be able to feed a context to your model that's actually based on some document or some web page or some other tools. The output parser, we have the models as well. The models is quite interesting because langchain actually abstract the model logic from the implementation, as I mentioned before. As you can see here, we have different models, right? So you'll see that only the model name, the provider, and maybe some API keys will change when we'll switch models. So if we switch to OpenAI, if we switch to Enthropic, we switch to Together, you'll see that you can easily change your application logic without having to completely change everything. You can easily change your API provider without having to change your complete application logic, which is pretty interesting. So let's say you're working with OpenAI and suddenly DeepSeek's cut costs by 10% or 50%. You want to switch there. Instead of re-implementing everything you did in your code with maybe the new DeepSeek API, the good thing or the best thing now would be to just change. If you used langchain before, would be to just change the provider, the model, and the API keys, and you're good to go. So in the last video, I showed you many providers, and most of these providers are actually supporting OpenAI API. It wasn't the case before. And even with that, you will see that just a fraction of what this model can do is actually supported with the OpenAI API base URL trick. So you still need to have an abstraction to be able to work with different models easily. And you can see down there that and langchain support a lot of models. So you can choose the one that suits you, local LLM, it's different providers from different, you can choose and integrate it into your app. And as I mentioned before, it will actually be the same thing. So I think Korea is one of the providers that we didn't talk about in this video. And you will see that the module that you're using, these human messages, this chat and everything in abstraction will actually be purely abstracted from the library itself. I think AI21 Lab is one of the providers as well. We have a video about where AI21 Lab and OpenAI when they were the three provider on the market. It's on the channel. You can check it out. Yeah, and as you can see, you will see that you have this implementation here, and you can have nearly the same logic with the chat prompting with the chain, where you put the LLM here, and you can change the LLM to any other provider. The same logic and the same code will work. So that's one of the powerful features of langchain. And now the tool ecosystem. This is one of the most important thing working with langchain. It is a tool ecosystem. So if you type langchain tools, you will see that I think it's this one. No, not this one. This one. Okay, you will see that you have a panoply of tools here. Okay, if you want to code this yourself, you will pass a lot of time coding a Bing integration, Brave integration, Google integration, and GitLab integration, GitHub integration. So you will see on this page that you have so many integrations that it makes it Google integration, Google Drive, that it makes it extremely easy for you to work with all of these tools. So if you're building an app that's supposed to connect to one of these providers, langchain is the right framework. Same for other providers that we'll be talking about here. So using a framework instead of building everything from scratch, using maybe OpenAI API will be better. So you don't have to recreate the where. You can just use the modules, give the folder maybe, and load everything from Google Drive. Building this is quite complex if you want to do it yourself. So using a framework is the right way here. Okay, so with that said, I can show you some sample code. We'll just build a sample langchain application later, but let's just go through the overview of all of this framework, and then we'll go through the code later. Here we'll see Haystack. Haystack is actually framework from DeepSeek, not DeepSeek, but DeepSeek. So let me show you how it's written. DeepSeek like this, not DeepSeek. Okay, DeepSeek like this. Okay. Yes. So they created it around the same time as langchain, and the specificity or the speciality of this framework is that everything is built as a pipeline. It makes it pretty easy for you to chain multiple process that look like a pipeline, that will fit into a pipeline. Especially document processing or document integration with tools and things like that. So you can see, for example, here in this image that you have generators, which are actually, just LLM providers, embedders to actually I will think we'll talk about it later, to compute embedding and save it. Retrievers to retrieve. These are vector stores, document, and then ranker, router, preprocessor, and a lot of these things that you can just compose and create a pipeline out of it. And the pipeline will be something like this: you get a query, you embed the query. Talk about it later again. You retrieve the query later on. You create your prompt, and you generate a response using one of these tools. So Haystack is actually quite interesting when you want to do retrieval augmented generation as well. But it's not limited to that. You can actually build AI agents with it, and many other things. Now, Llama Index. Llama Index was first called GPT Index, and it was a module built on top of langchain to specially work with documents. I think they extended it, they changed some modules. Now they are being a bit more independent from langchain, but at the core of it, it was mainly built to work with documents. And that's the reason why I mentioned we cannot really use these frameworks without talking about retrieval augmented generation. But in general, it's kind of the same thing. If you go to Llama Hub, you will see that. Let me go to Llama Index Hub. You'll see that we have kind of the same thing, right? We have kind of the same tool that you have with langchain. So if you search for data loaders, you'll see that you have here web page loader, Reddit reader. I don't know if you have Drive here. Google Drive reader, Google Calendar reader. So we nearly have the same loaders, right? It's actually the same ecosystem as langchain, nearly the same, just that it's purely built for data. So it's mainly interesting to work with Llama Index when you want to work on top of data. Yes, so that's the reason why you can see here that you have this vector database, vector database, and integration with tools. And Llama Index actually orchestrating working with all of these tools, the database, and the providers as well. Basically, all of these tools actually help you build AI application easily. Langchain is helping you with the ecosystem and compose them to build complex application. It can be AI agents. Langchain actually have an AI agent framework. We'll see that in the upcoming modules of this video called LangGraph. Haystack is actually interesting as well to build application using the pipeline architecture. And then Llama Index is quite interesting when you want to work on top of data or documents. Okay, so let's go through some sample code. I'll just show you some sample code of langchain, Haystack, and Llama Index, and we'll go through it together. Okay, so here we have our framework folder. Okay, it's empty for the moment. So let's create a new terminal. Okay, it's already there. Then we go to the framework. First thing first, we create a virtual env. Then resource vm /bin /activate. So that's done. Now we need to come here and create a .env. So that's the first thing. Why? Because we'll be working with providers, and the best way to keep our API keys secure is to create a .env. So let's do .env here. I'll be pasting some keys here. I'll actually show how to do this in last tutorial, so you can watch it again if you want to see how to create an API key and other. So what we'll be doing here is that we'll be giving the document loading functionality to OpenAI. If you see it from the Gemini point of view here, we did document loading, PDF loading. For Enthropic, same. We were able to load PDFs directly, but unfortunately, we don't have the same functionality. We don't have it here anymore. But unfortunately, we don't have the same functionality with OpenAI. So we'll try to give that functionality to our OpenAI API today. So let's create a file. The first example will be with langchain test. And don't name your file langchain, otherwise we'll have a problem with importing your modules. Okay. With this, what we need to do is first install all the required modules to work with langchain, right? And these required modules are quite simple. Let me just put a requirement.txt here, requirements. .txt. In this requirements file, we'll put langchain community, langchain core, langchain OpenAI, basically langchain modules, and we can actually install that just by keep installing langchain and all the providers that are related to langchain. But I think we have it here first. Okay, here, put it here. Python. We also need the dot here .env. Okay. Okay, so now we can install these modules and start using it. So here, pip install. Yeah, we need some PDF processing part as well. So let's put this here for reading our PDF and transforming it into documents. Install requirements. Okay, installing everything. And then what we need to do is to import first all the modules that we'll need. And for that, we need to import the OpenAI chat. Need to here. First install OpenAI, import it. We need a prompt template. I think we talk about prompting and the prompt template that langchain comes with it. You will see how to use it here. And then we need to install the PDF loader here. And as usual, we need to load our .env, our environments, to load the OpenAI key into our environment. What langchain is doing actually is that it's getting the key directly from the environment, so you don't have to pass it directly. But if you can actually pass it if you want to, but it will read a variable called OpenAI API, OpenAI API key, the way we have it in our .env already, so it's fine. So with that, what we need is to create a PDF here, and this PDF will be what we will be working with. Okay, so let's paste the PDF here. Okay, this PDF is actually just some it's how's it called, RFS from request for startup from your YC, and we'll be just building something that will read through it and just summarize it quickly. And you can build some things to suggest startup ideas directly based on this RFS as well. You are free to exploit it as you want. In this video, we'll just be summarizing the content. Okay, so with that document, what we need is to load the content, and to load the content we use this by PDF loader. It's pretty simple. You will see that we have here by PDF loader, we pass the name of the file and we load the file. This PDF will be loaded into different documents. So if we print this, print documents, okay, and we go in our, let's clear this, and we do pip or Python langchain test. Taking some time, and you will see that we have many documents here, okay, with the metadata like total pages, the actual page, the page label. So maybe if you extract something from a specific page, this is actually made for RAG, and we'll talk about it later again. But if you extract something from a specific page, you can actually highlight it and give it as a source. But here you will see that it read the PDF and cut it into chunks or into documents, not chunk, into documents. And you will see the page actually request for startup. At YC, we often discuss ideas that we'd like to see more people working on. So with that said, we can delete this. And our next thing will be to merge all of this document. For the moment, we do not do vector storing, semantic search, and things related to RAG. I will just be feeding the whole document to the AI. In the RAG part, we'll be optimizing this to make sure that we only feed the part that we need to the AI. But okay, for the moment, we'll just go through the documents and merge them. Okay, we're going to the next line after each document. And then with that, we need a prompt template. This prompt template is actually a custom prompt template where we have two input variables. We have here the PDF content and the query. Okay, so you can create a prompt template like this and use it in multiple apps if you want to. You just have to pass these two variables, the prompts, the PDF content and the query every time you call the prompt template. And then we create our LLM instance. Okay, so here we pass the model name. It can be GPT-4o as well. I'm just trying to be cheap. We pass the temperature, and then we have our chain. So what we do here is that we compile our prompt like this. We pass a query variable and a PDF content. So the query variable, we need to create it. It will be this one, saying summarize the key insight from this report. It will just go through the PDF that we loaded here. That will be passing with this variable down here, and send it to the LLM to summarize. So how do we do to send it to the LLM? We do LLM.invoke and we pass the prompt, which will have this variable replaced already and this variable replaced as well. So, okay. And after, we just print the response. So if I clear this and I run it again, taking some time, and you will see the response from the AI here. The report outlined a list of startups in the AI and software engineering space, including secure AI app store, data center, compliance, and audit. So this is a good summary of the document, but this is quite bad in terms of implementation. Why? Because you are feeding a 5-page document to the AI, which is pretty expensive. In the RAG part, I will show you how to cut this document and just feed the specific part that the AI needs to know to answer the question. Okay, so langchain test is done. Let's do the same with haystack. Haystack test.py. Okay, but to work with haystack, we need to install haystack modules and modules from py. And for that, we need haystack AI. So let's add it to our requirement and install again. You will install the missing modules. Let's just install everything with llama index and everything, so we don't have to do it every single time. Okay. Okay, I think everything is installed. So with haystack, we have kind of the same process. Okay. We first, of course, import the modules. Let's just import everything directly here. This will help to read the file. This is actually an internal package, an internal object of haystack to actually help you build pipelines. And these pipelines are based of components, and these components will just be what you will be putting into your pipeline. It can be retrieval, it can be a tool, it can be a provider, but in general, you need this component into your pipeline. Okay, so now that we have this, as usual, we need to load our env variable to be able to use it later. Okay, great. So now, same, we need a prompt template, but this prompt template will just be simply a template like this. And for a haystack compared to langchain here you have one single bracket. Here you need double bracket. And what's interesting here is that it works like a template engine, which means you can do for loops in there if you have an array, for example. Okay, so with that said, let's create our pipeline. We have this. Okay, and then we add some components to our pipeline. So we first add the prompt. So our pipeline starts with the prompt. I think we need to do this. Then we have the AI that will get the result from the prompt. The complete prompt will get the AI, will be fed to the AI, and the AI will generate something that the answer builder will take. You just added component here. Now you need to create the logic, and the logic will be connections, which we'll do here. And then we connect this like this. Yeah. So it's just saying that our prompt builder here is connected to LLM, and our LLM replies will be fed to the answer builder replies. So this will look like a pipeline. You can actually grow it like this to see how it looks like.
So let's do that, and we need to just Python haystack. It will, if everything's right, it will create a file here, and this file will be this. Okay, so I'm just zoom through it. You see that we have the prompt builder that takes PDF content, question, and some other variables. This prompt is a string at the end that's passed to the LLM here, and this LLM get the system prompt, streaming, callback, and other, and send replies to the reply builder, and the reply builder will just generate the result with it, and the metadata if needed, the meta as well. So, yeah, so we get it here. So what we need now, we have our pipeline already built and visualized here. We just need to call it, okay? And to call our pipeline, we need to feed the information that we have, which is actually the PDF. And to do that, you need to call the PDF module and convert it into documents, okay? We read it and we convert it into documents, and we do the same that we did with langchain. We transform that and save it into a single variable. Normally, this document, you save it in the vector store, but in our case, we're merging them and putting it into a document. Now, we have the query, which is our question here, same as langchain. And then we just run our pipeline, okay? Running the pipeline is as simple as doing this. From builder, question, you pass a question, PDF content, you pass a PDF question. These are actually what you get here. This and this is actually the parameter of your prompt builder, right? That's the reason why you're passing it here. And each of the pipeline component, if it needs a specific input, you need to pass it as a parameter here. Okay. So great. Now we can print the result. Like this. Just okay, and then run it again. Taking some time. So in the meantime, I can create directly llama index. Apply. You can see that it worked properly, right? We have the report here. We built our pipeline and we feed and we run it here, okay? And it's working properly. So now for llama index, it's nearly the same process, okay? First, we import the modules, okay? Same. We have this. This is quite specific. That's the reason why we have this PyMu PDF here. We install this. We use OpenAI path, as I mentioned, to read the file on the system. Chat message load.env to load the environment variables. So we load them here. Okay. Now we need to read the PDF, and same. You will see that they actually have the same high-level logic most of the time, but the architecture is quite different. So here we merge them. I actually explained that already. We create a prompt, same, but this prompt is actually just a normal Python template. And then here we create our LLM with the model and temperature. And as usual, the API key will be directly extracted from the environment variables, okay? And then here we create a message. This is actually quite close to OpenAI. So we imported the message module, the chat message module here, and we create the system and the user message here. And then all we need is just to run this by doing this and then printing the response, okay? And then let's run this Python llama index test. Taking some time. Okay, great. So we get the document outline, very startup AI and technology. You'll see that llama index is quite fast. It is purely optimized to work with documents. This is a really simple use case, but you can do complex things on top of document with llama index. Yeah. So I think that's it for this video and for this module. In the next part, we'll talk about retrieval augmented generation, where you will understand in depth how to work with documents and how to work with tools, and also how to use these frameworks to make this whole process pretty easy. So thank you for watching and see you in the next video.